Hi everyone, I welcome you all to the live session on R Programming Full Course by Intellipaat. This session is conducted by multiple experts who will be teaching you all about R programming from basic to advanced level. But before we begin, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. In the world where we are surrounded by data science and data analytics always take the center stage. R programming is the biggest asset to data scientists and data analysts. On saying that, let's see the agenda of the day. Firstly, we will begin with introduction to R programming. Then afterwards, we will be seeing what are variables and objects. Then later on, we will see flow control statements. Then after that, we will be seeing ANOVA concept. Post that, we will be learning about data mining using R. Then after that, we will be doing a hands-on projects on book recommendation system. Then after that, we will be seeing the difference between R programming and Python. Then lastly, we will be covering R programming interview questions and answers. Now, let's begin the session.
So what is R? So R is a language developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, R should be a go-to language. Now R is also a great visualization tool. So R provides packages such as ggplot2 and plotly so that you can create stunning visualizations. Now R is an open source cross-platform compatible software. So it's just plug and play. All you have to do is install R once and then you can start having fun with it. And since R is an open source software, you can actually modify the code and add your own innovations to it. And being cross-platform compatible, you can actually run the same R code on different operating systems. And the best thing about R is it is a Turing complete language. That is, it can perform any task which a Turing machine can. Now that's amazing, isn't it? And this is what makes R such a powerful tool. So you can do various operations such as statistical analysis, implement machine learning algorithms, and also create stunning visualizations, all with the help of this super language called as R. So now that we know what exactly is R, let's go ahead and install R and R Studio in our systems. So we can install R from the site over here. So we can go to cran.rproject.org. Right, so we have different versions of R. So if you are using a Linux system, then you can download R for Linux. If you're using a Mac system, then you can download R for Mac. Similarly, if you're using a Windows system, you can download R for Windows. And since I'm using a Windows system, I'll click on this link. Right, so you see this link over here, install R for the first time, click over here. Now this is the latest version of R 3.5.1. So you have to click on it and then the download would start. Now since I've already downloaded R in my system, I'll go ahead and cancel this. Right, now after you install R, you would also require an IDE so that you can perform your tasks quite easily. So one such IDE is R Studio. So R Studio is a free open source software which provides a smooth interface so that you can perform all of your operations quite easily. And you can download R Studio from this site over here, rstudio.com. So let's go to rstudio.com and download R Studio. Right, so we have entered the site. I'll click over here, download R Studio. And we see the free version over here, R Studio Desktop Open Source License. Again, I'll click on download and you see different versions of R. So again, if you're using a Windows system, this is the right link for you. If you're using a Mac system, you can download R Studio for Mac. Similarly, if you're using a Ubuntu or a Fedora system, you can download these versions. And again, since I'm using a Windows system, I'll click on this link. Right, the download has again started. And since again, I already have R Studio installed on my system, I will cancel this. Right. So we have successfully installed R and R Studio in our systems. Now let's go ahead and understand what exactly is a variable. So simply put, a variable is a temporary storage space. So let's understand the concept of variable with this example over here. So let's say we have this cart and this cart would be our temporary storage space. Now I also have an apple with me and I decide to store this apple inside this cart on a temporary basis. Now, after some time, I decide to remove that apple and replace it with a banana. Now again, after some time, I decide to replace that banana with a mango. So this is the basic premise behind a variable. It provides a temporary storage space where we can keep on changing the values. Right, so now that we've understood what exactly is a variable, let's head on to RStudio and implement some variables. Right guys, so this is how RStudio looks like. So we have 4 panes in total. This is the script window, this is the console window, this is the environment pane, and this is the tab where we can install new packages and also build some plots. Right. So what I'll do is I will create a new variable and name that variable to be fruit, and I will assign it a value of mango. Now I will select this and paste it inside the console window. Now let me print fruit. So I get the result mango over here. And since fruit is actually a variable, I can change the value which is present inside it. So again I will type in fruit, and this time I will assign a value of apple. So I will paste it in the console window. Now let me print fruit. So see that the initial value of mango has been replaced with apple. Similarly, I'll create the same variable and I'll change the value. So this time the value which I'm assigning this would be a banana. Let me paste it over here. Now let me type in fruit, let me print it. So we get a banana. So this is how a variable works, guys. So this is a temporary storage space where the values can be kept changing again and again. So what I've basically done over here is I have taken a variable fruit. Initially I had assigned a value mango, after which I had replaced that value with an apple, and again I had replaced the same value in the same object with banana. Right. So now that we've understood what exactly is a variable, so each variable is basically associated with a data type. So let's start off with the first data type, numeric. So a variable can store numeric values such as 5, 1000 and -33. So after numeric data types, we have the character data types. So a variable can also have character values such as these. So a character value could be either a single character Z, or it could be the word Sparta, or it could be 2 words such as hello world. Right. Now after the character data type, we also have the logical data types. So a variable can store logical values such as true or false. Now you guys need to keep in mind that in R, by convention, this needs to be in capital, right? So this keyword true is capital and this keyword false is also capital. And then we have the final data type, which is complex. So a complex data type basically comprises of 2 parts. First is the real part, and then we have the imaginary part over here. So 2 plus 5i, 30 minus 30i, and minus 100.47i, all of these are complex data types. So similarly, a variable can also have complex data types. Alright, so now that we've understood what exactly are data types, let's go to RStudio and implement some variables with different data types. So I'll start off by creating a variable which would have a numeric value. So I will name this as my obj, and first I will assign it a numeric value which is 123. Now I can use the class function to have a look at the class of the object. So let me type in class, and inside this class function I will pass in the object which I've just created, which would be my obj. Right. So the class of this object is numeric. Now what I'll do is, to the same object I will pass in a character value. So let's say I will pass in the word Sparta to this. Let me hit enter. Now let me have a glance at the class of this object. Class of my obj. So now we see that the class of this object is character, right? So initially the class of this variable was numeric, but then when I had assigned a character value to the same variable, the class changed to character. Now I'll go ahead and assign a logical value to this. So let's say I assign a true value to this. Now again let me have a glance at the class. So class of my obj. So this time this is of logical type, right? Now finally let me assign a complex type to this. So my obj, and using this assignment operator, let's say I would give this a value of 30 plus 100i. right? Now let me use the class function and have a look at the class of this object. So that would be my obj. Right, so the class of this object is complex. So what we basically understand from this is, as we change the type of the value given to the object, the class of the object also changed. So we started off by assigning a numeric value to the object. Then when we saw the class of that object was numeric, then we had changed the value and we had assigned the same object a character type, and that's class changed to character. Right? So this basically means that if we change the value given to the variable, the class of that variable would also change. Right, so these were data types in R. Now let's have a look at the different operators which are available in R. So these operators basically help us to perform some sort of mathematical or logical operations on top of our variables. So basically we have these four operators in general. So we can have assignment operators, arithmetic operators, relational operators, and logical operators. So let's start off with the assignment operators. So as you can see what is stated over here, assignment operators are basically used to assign a value to an object. And these are the three different assignment operators available in R. So we can just use the equal to operator to assign a value, or we have this another symbol over here. So here we have a less than operator, after which we give a hyphen. So this is another type of assignment operator. Here again we have the hyphen followed by a greater than symbol. This is another type of assignment operator. And if you have a look at this, we have some examples over here. So what we are doing is we are assigning the value of 10 to this variable x using this assignment operator. Similarly here we are assigning this value 20 to this variable y using this assignment operator. And similarly we are assigning this value of 30 to this variable z using this assignment operator. So again, let's head to our studio and we will be implementing some assignment operators and assigning some values to some objects. So let's say I create the same variable x. So I will put in the variable name which is x, after which I will give in the assignment operator which is equal to, and I will give in the value now. So let's say the value which I want to give this is 10. Right. Now similarly I will assign a value to the variable y. So I will give in the name of the variable which is y. And then I will use another variation of the assignment operator. So first I will give in the less than operator, and then I will give in a hyphen, and the value which I give is, let's say 20. So I'm basically assigning the value 20 to this variable y. And then I will give the value 30, and I am assigning this value 30 to the variable z. So this is basically inverse assignment. So first I give in the value, and after giving in the value I would assign it to the variable. Right. Now let me print x, y, and z values. So x, y, and z. So we have successfully assigned the value of 10 to variable x. We have assigned 20 to variable y, and we have also assigned 30 to variable z. Right, so that is how we could work with assignment operators in R. Now let's head on to arithmetic operators. So these arithmetic operators are used to perform basic mathematical operations. And these are the different arithmetic operators which we have in R. So this plus symbol over here helps us to add two variables. Then we have this minus symbol which helps us to subtract two variables. Then we have this asterisk symbol which helps us to multiply two variables. And finally we have this forward slash which stands for division. Through the help of this we can divide two variables or two operands. Right, now we are back to our studio and let's perform all of these arithmetic operations. So I'll start with addition first. So we had just seen that we had created three new variables x, y, and z. So we will be performing all of those arithmetic operations on these three variables x, y, and z. So I'll start off by adding these two variables. So x, which is the first operand, then I will give in the operator which is plus. After which I will give in the second operand which is y, and we get the result which is 30. So the initial value of x was 10 and the initial value of y was 20. And when we add 10 plus 20, we get the value to be 30. Right. Now similarly, let me perform another addition operation. So this time let me add y plus z. So the initial value of y was 20 and the initial value of z was 30. And when I add these two, I get a value of 50. So these were some addition operations. Now let me perform some subtraction operations. So I want to subtract y from z. So I will give in the first operand, which is z, and I will give in the operator, which is minus, and then I will give in the second operand, which is y. So I am subtracting y from z, and this is what we get. So z is 30 and y is 20, and when I subtract 20 from 30, I get 10. Now let me subtract x from z, and let's see what do we get. So this time what I'm doing is, so the z value is 30 and x value is 10, and 30 minus 10 gives us a value of 20, right? So these were some subtraction operations, after which we'll start with the multiplication operations. So let me multiply x with y, and let me see what do we get. So x value is 20, so x value is 10 and y value is 20, and when we multiply 10 with 20, we got a value of 200, right? Now similarly, let me multiply y with z, so y asterisk z, let me hit enter, so we get a value of 600, because y's value is 20 and z's value is 30, and 20 cross 30 gives us a value of 600. So these were some multiplication operations. Now let's head on to division operations, right? So let me divide z with y, and let's see what do we get. So z's value is 30, y's value is 20, and 30 by 20 gives us 1.5. Now let me do y with respect to x. So this would be 20 divided by 10, and this would give me a value of 2. Right, so these were some arithmetic operators. Now let's look at relational operators. So these relational operators are used to compare two operands. So these are all of the different relational operators which we have. So this is the less than operator, and this helps us to find out if the first variable is less than the second variable. Then we have the less than equal to operator. So this helps us to find out if the first operand's value is less than the second operand's value. Then we have the greater than operator, and this helps us to find out if the first operand's value is greater than the second operand's value. And then we have the greater than or equal to operator, and this helps us to find out if the first operand's value is greater than or equal to the second operand's value. And then we have the is equal to operator. So here we just given two equal to's, and this helps us to find out if the values of both the operands are equal. And thus finally we have the not equal to operator. So first we give in the exclamation mark, and then we give in the equal to symbol. So this helps us to find out if the first variable is not equal to the second variable. Again, let's head back to our studio, and let's implement some relational operations. So let me check if the value of x is less than the value of y. So I get a true value because 10 is less than 20. Now let me check if x is less than or equal to y. Now this again is true because 10 is less than or equal to y. Now I will go ahead and check if x is greater than y. So this time I actually get a false. So this is because 10 is not greater than 20. Right. Now similarly, let me check if x is greater than or equal to y. This again is false because 10 is neither equal to nor greater than y. Now let me go ahead and check if the value of x is actually equal to the value of y. So this time again I get a false value because 10 is obviously not equal to 20. Now let me check if x is not equal to y. So this would obviously be true because 10 is obviously not equal to 20. So these were some of the relational operators. And then we have the logical operators. So the logical operators are basically used to make a decision on the basis of a condition. And the two most majorly used logical operators are the AND operator and the OR operator. So this is the AND operator. So let's have a look at this table to understand how does the AND operator work. So we have two conditions over here, and if both of those conditions are evaluated to true, only then the AND operator would give a true result. So let's take this case over here. So here the first condition is evaluated to false, and the second condition is also evaluated to false, and that is why the result which we get is false. Let's take the second case. So over here the first condition is evaluated to false, the second condition is evaluated to true. But since both of the conditions are not evaluated to true, the final result is false. Again, let's have a look at this third case. here the first condition is evaluated to true, but the second condition is false. And that is why the final result is false. So let's take this final case. So over here, this is the only case where both of the conditions have been evaluated to true. That is, the first condition is also true and the second condition is also true. And that is why the final result which we get is true. Then we have the OR operator. So the OR operator gives us a true result when either of the conditions is true. So let's take the first case here. The first condition is evaluated to false. The second condition is also evaluated to false. And since both of the conditions are evaluated to false, the final result is false. Then we have the second case over here. Here, the first condition is false and the second condition is evaluated to true. And since the second condition is evaluated to true, the final result is true. Then we have this third case. Here, the first condition is evaluated to true, but the second condition is evaluated to false. But since at least one of the conditions is true, the final result is true. And thus obviously we get a true result because both of the conditions are resulting true. Now let's go to RStudio and implement these logical operators. Right. So let me give the first condition. So the first condition would be x is less than y. Then I will give in the AND operator and I will put in the second condition. So the second condition would be x is less than or equal to y. Now let's examine this command properly. So x is less than y. This means that 10 is less than 20, which is true. Now let's examine the second condition. So over here, 10 is less than or equal to 20. This again is true. So true and true would give us a true result, right? Now let me change the conditions. So let me give the first condition to be x is greater than y. I will give in the AND operator. Now let me put in the second condition. So the second condition would be, let's say x is not equal to y. So here x is greater than y would be yielded to false because 20 is not greater, because 10 is not greater than 20. Then let's examine the second condition. This would be evaluated to true. So 10 is obviously not equal to 20, but the final result is false because one of the conditions is evaluating to false. So this was the AND operator. Now let's work with the OR operator. So again, let me give in the first condition. So the first condition would be x is not equal to y. Now let me use the OR operator and let me give in the second condition. So the second condition is, let's say x is greater than y. So guys, what do you think would be the result over here? So we get a true value. This is because the first condition yields a true value. So 10 is obviously not equal to 20. But even though the second condition is yielding false, since we have at least one condition which is yielding true, the final result is also true. Now let me do a variation over here. Now let me give in two false conditions and let me see what will happen. So the first condition would be x is greater than y. Then I'll give in the OR operator and then I'll give in the second condition. So let's say the second condition is x is equal to y. So this time we get a false value. This is because first condition is false, the second condition is also false. And when we use OR operator with two false conditions, the final result is obviously false. Right, so these were some of the operators in R. Now let's go ahead and understand objects. So basically every data element in R is an object. As simple as that, guys. I'm reiterating it. Every single data element is basically an object in R, and these are the 6 most basic used objects in R. So we have a vector, matrix, factor, list, array, and a data frame. So let's start off with the most basic object, which is a vector. So a vector is actually a linear object which contains elements of same type. So elements of same type, or in other words, elements which are homogeneous. And this is the syntax to implement a vector in R. So you will be using the C function or the combine function, and you will be passing in all of the elements. Right? So over here, I am using the C function to pass in 3 elements, which are the numbers 1, 2, and 3. And similarly over here, I am creating another vector where I'm passing in 2 elements, which are true and false. So let's go to RStudio and create some vectors. Right. So I will create a vector. And I'll name that vector to be my vector. Now using the assignment operator, let me assign some values to this. So I'll be giving only the elements of same type. So let's say I will give in elements of only numeric type this time. 1, 2, and 3. So this vector comprises of 3 elements, and all of those 3 elements are of numeric type. So let me have a glance at the class of this. So class of my vector. So we see that this is of numeric. Now what I'll do is, to the same my vector object, I will assign elements of different type. So this time I will be passing in elements of character type. So let's say the first element is character A, the second element is character B, and the third element is character C. Let me hit enter. Now let me have a look at the class of this. So class of my vector. So see that this time it is a character. Now again, to the same object, which is my vector, let me assign logical values. So the logical values would be true, false, and true. Now let me check the class. So that would be class of my vector, and this is logical. So you see that the class of the vector is basically determined by the elements which are passed to it, and all of the elements are basically homogeneous. Now what I'll do is, I'll actually pass in elements of 2 different types to the same vector, and let's see what would be the result. So the name of the vector is my vector. I will use in the C function or the combine function, and this time what I'll do is, I will pass in 2 numeric elements first, and after passing in 2 numeric elements, I will pass in 2 logical elements, true, false. So this is a vector which comprises elements of different types. So the first type is numeric and the second type is logical. So guys, what do you think would be the result? So do you think there would be an error, or we would be getting some other result? So let's see what we'll actually get. So let me print in my vector over here. So this is quite a strange result, isn't it? So we had actually passed in 1, 2, true, and false, but the result which we are getting is 1, 2, 1, and 0. This is because the logical values have been coerced to numerical values. So this means that a vector can have only homogeneous values. So the value of 1 and 2 are the same. So 1 is a numeric value, it remains as 1. 2 is a numeric value, it remains as 2. But this true logical value over here, this has been coerced to a numeric value of 1. Similarly, we have this false logical value over here, and this has been coerced to a numeric value of 0. Right. So this time I will pass in character values and logical values to the same vector. Let me name that vector to be my vector, and let me use the C function to assign some values. Right. So let's say the first 2 elements are characters. So the first element is the character A, and the next element is the character B. After this, I will give in 2 logical values. Again, there would be true and false. Now guys, what do you think would be the result for this? So let me just check. So that would be my vector. Right. So this time the logical values have been coerced to character values. So A and B were initially character and they remain as character. But these 2 values which were actually logical, their values have been coerced to character. So just to verify it, let me show you the class of this character. So class of my vector, this is a character. So even though I had passed in 2 character elements and 2 logical elements, the class of both of the logical elements has been changed to character, and the class of the entire vector is also character. Right. Now finally I will pass in all of the elements of the 3 different types. So I will pass in 2 numeric values, 2 character values, and 2 logical values. So I will pass in 2 numeric values which are 1 and 2. After this I will pass in 2 character values which are A and B. And then I will finally pass in 2 logical values which are true and false. Now let me hit enter my vector. So this time all of the values have been coerced to character. So this means that character data type has the highest precedence, the numeric values has the next highest precedence, and the Boolean values or the logical values would have the lowest precedence. Right? So again, just to verify, let me show you the class. So that would be class of my vector. So this is a character. So even though we had passed in elements of 3 different types, the class has been changed to character. So let me print in my vector again over here. So these are the 6 different elements which are present in this vector. So now I'll go ahead and show you guys how to extract individual elements from this character. So let's say I'd want to extract this 4th element from this vector. So let's go ahead and do that. So for that, I would have to give in the name of the vector first, which would be my vector. After that, I will give in 2 square braces. And inside that square braces, I will give in the index number. So the index number is 4 over here. So the numbering starts from 1, guys, right? So this is index number 1, 2, 3, 4, 5, 6. And since I want this element over here, the index number would be 4. Right. So this is how we can extract the element B from this vector. Similarly, if I wanted to extract this 6th element over here, all I have to do is give in the name of the vector, which would be my vector. I will give in 2 square braces, and inside that I will give in the index number, which would be 6.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash: A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Right, so we have extracted this false value. Now, let's say we wanted to extract only the alternate values or the alternate indexes from this vector. That is, the 1st, 3rd, and the 5th values from this entire vector. So for that, I would have to give in the name of the vector. Then I'll give in 2 square braces, and using the C function or the combine function, I'll be selecting the 1st, the 3rd, and the 5th index. Right? So from this entire vector, I have extracted the 1st element, the 3rd element, and the 5th element. Now, similarly, if I wanted to extract all of the elements starting from index number 2 to index number 5, this is how we can do it. So I will type in my vector over here. I will give in square braces. I will put in the 1st index number, which is 2, and then I will put in a colon, and then I will give in the last index number, which is 5. So like this, we can extract all of the elements starting from one particular index to the last index. So let me hit enter. So we have extracted all the elements starting from index number 2 to index number 5. So that is how we can work with that. So that is how we can work with vectors. So next we have lists. So list is actually similar to a vector, but the only difference is a list can contain heterogeneous elements. That is, even though if you pass in elements of different types to the same list, they will be not coerced to the data type of higher precedence. So let's take this example over here. So this is how you can create a list. So first you will use in the list function, and then you will give in the individual elements. Now we see that one element is of numeric type and the other element is of character type. Now, even though this is of numeric, this will definitely not be coerced to character type. So this is the speciality of a list. So you can pass in heterogeneous elements where the heterogeneous elements will not lose their core identity. Right, so let me create the first list and name that list to be my list 1. And I'll use the assignment operator again. I will use the list function. Right. Now using the list function, what I'll do is I'll pass in 3 different elements. So the first element would be a numeric value 1. The next element would be a character value A. And the third element would be a logical value true. Let me hit enter. Now let me print out the list. So let me show you guys how does a list look like. So my list 1. So guys, this is how a list looks like. So see that there are 3 different components over here. There's the first component, second component, and the third component, right? So this first component contains the numeric value 1. The second component contains this character element A, and this third component contains this logical element true. Now let me show you guys the class of each of these individual elements. So let me show you how to extract individual elements first. So my list 1 Now let's say I would want to extract the second component. So if I want to extract the second component from the list, I will give in square braces. Now inside the square braces, I will give in another set of square braces. Now inside this, I will give in the component number. And since I want the second component over here, I will put in 2. So this is how we can extract the second component from this entire list. Now let me have a glance at the class of this. So class of, I'll give in the name of the list, which is my list 1. I'll put in 2 braces. Inside the braces, I'll give in another set of braces. And let me give in the component number, which is 2. So you see that this is of type character. Now similarly, let me check the class of this component over here. So the component would be 3. So the class is logical. Now let me check the class of this first component over here, which is 1. So numeric. So you see that even though we are assigning elements of different type, these elements are holding on to their true classes or to their true data types, right? So the numeric value stays as a numeric value, the character value stays as a character value, and the logical value stays as a logical value, right? So now I'll go ahead and create another list. So I will name this list to be my list 2. And this time what I'll do is I'll use the list function and I'll pass in 3 vectors inside this list. So I will pass in a numeric vector inside this. So I'll use the C function, and the numeric vector would comprise of these 3 elements 1, 2 and 3. After this will comprise of a character vector, and the character vector would comprise of A, B and C. So let me change this to small b over here. Then I'll pass in the third vector or the third component. So the third component would comprise of logical values, and the logical values are true, false and true. Let me hit enter. Now let me print out this list. So let's see what do we get. So it's my list 2. So this is the list, guys. So this is the first component, this is the second component, and this is the third component, right? So the first component contains a vector of 3 numeric values. The second component contains a character vector of 3 different individual characters. Then we have the third component, which contains a vector of 3 logical values. So now let's understand how can we extract individual elements from this sort of list. So let's say I wanted to extract this element from this entire list. So this element is present at the second location of the second component, right? So first I would have to give in the name of the list, which would be my list 2. After this, I will specify the component. So 2 square braces. Inside that, I will give in another set of square braces. So now let me specify the component number, which is 2. After this, I will give in the element position. So in the second component, or from the second component, I would want the element present at index number 2. So I will give in 2 over here. And we have successfully extracted this value. Now similarly, let's say if I wanted to extract this true value from this third component. So this is element number 1 at component 3. So I would have to give in the name of the list, which is my list 2. So I'd have to specify the component number. So the component number is 3. Then I'd have to specify the position where the element is present. So it is present at first position. So from the third component, I am extracting the first element and we get the true value, right? So this is how we can work with lists. Now let's go ahead to the third object, which is a matrix. So matrix is not actually a linear object. It is a 2-dimensional object. So when I say 2-dimensional object, it would have both the rows and the columns. And this matrix would contain only homogeneous elements or elements of similar type. And this is how you can create a matrix. So we can use the matrix function. So this matrix function first takes in the data where all the elements come from. After this, we specify the number of rows present in the matrix. So this is the result for this command over here. So when we specify the number of rows to be 2, we get the number of rows to be 2 over here, right? So this is how a matrix looks like. So we have rows and we have columns, and all of these elements are coming from this data over here. So let's head to our studio and implement a matrix. So let me use the matrix function. I'll type in matrix over here. Then let me pass in the data. So the data which should be present in the matrix should be coming from this vector, and this vector would be comprising of the elements 1, 2, 8. So let me hit enter and let's see what do we get. So this is the matrix which we get. So we have 8 rows and 1 columns. So if we do not specify the number of rows in the matrix, then it automatically assigns each element to a new row. So since we have 8 elements over here, we have 8 rows and 1 single column. So let me go ahead and use the n row parameter to set some predefined number of rows. So let's say I'd want 2 rows in the entire matrix. So the n row value would be 2. Right. So this is our matrix, guys. So we have 2 rows and 4 columns. Now what you see over here is these elements are arranged with respect to column and not with respect to row. That is, so this is 1, 2, 3, 4, 5, 6 and 7, 8. These are arranged with respect to the column. So if I wanted these to be arranged with respect to the row, I have the by row attribute and I will set this by row attribute to be true. So these elements which were actually aligned with respect to the column now have been aligned with respect to the row. So 1, 2, 3, 4 are in one row and 5, 6, 7, 8 are in another row. So I will store this in a new object and name that object to be mat1. Right, now let me print mat1 over here. So this is our matrix. Now let's understand how can we extract individual elements from this matrix. So let's say I wanted to extract this element over here. So this element is present at row number 2 and column number 3. So again, I would have to give in the name of the matrix, which is mat1. Then I will give in the square braces over here. Inside the square braces, I will first specify the row number. So the row number is 2. Then I'll put in a comma. After that, I will specify the column number. So the column number is 3. Let me hit enter. Right, so this is how we have extracted the element or the value 7 from this entire matrix. Right, now let's say I wanted the element this 5, 7 and 8 from this matrix. So let's do that. So again, I would have to give in the name of the matrix, which is mat1. After that, I will give in 2 square braces and from the second row. So the row number is 2, which I'd given, and I would require the element which is present at column number 1, 3 and 4. So I will use the combine operator and I will specify the column values which are 1, 3 and 4. Right? So this is how we can extract these individual elements. And similarly, let's say if I wanted to extract this entire row from this matrix. So for that, I would have to type in the name of the matrix, which is mat1. I will use the square braces. So I will give in the row number, which is 1. And since I want all of the columns from this row, I'll not assign anything over here. So I'll just leave it to be blank. Right? And voila, we have extracted all of the elements which are part of the first row. Right, so that is how we can work with the matrix. Next, we have an array. So arrays are basically just an extension to a matrix. So matrix was a 2-dimensional object. So arrays, since they are an extension to matrix, they have more than 2 dimensions. And the elements which are stored in an array, they are all homogeneous. So this is the syntax to create an array. You use the array function and then you pass in the data values. After that, you set the dimensions. So this, what you see over here, 3, 3, 2. So this basically tells you that we will be getting 2 matrices which would have 3 rows and 3 columns each. Right, so if this seems too confusing to you, let's go to R and let's actually create an array by ourselves. So to create the array, let us first create the vectors which would be passed in as the data elements inside the array. So let me create the first vector. I'll name that first vector to be v1. And the values in this vector would be all of the numbers starting from 1 to 8. Now I will create another vector and name that vector to be v2. And the elements which would be there in this vector are the numbers starting from 9 to 16. Let me hit enter again, right? So let's have a glance. v1 is all the numbers from 1 to 8 and v2 is all the numbers from 9 to 16. Now I can go ahead and create the array. So I will use the array function. Now let me give in the data. So the data is coming from those 2 vectors over here. I will use the C operator to combine those two vectors. First vector is v1, second vector is v2. So we have successfully given the data. Now let me set the dimensions, right? So let's say I would want two matrices where I have where I want each matrix to have 2 rows and 4 columns. So I will use C. So I will given the first value, which would be for the row. So I would want 2 rows, I would want 4 columns, and I would want 2 such matrices. So this is what we get. So this dim value of 242 basically states that I have 2 matrices which are of 2 cross 4 type. So each of these matrices has 2 rows and 4 columns. So let me store this in a new object and name that object to be ARR1. Let me print ARR1 now, right? So this is our resultant array. Now let's understand how can we extract individual elements from an array. So again, I would have to give in the name of the array, which is ARR1. Then I will give in the square braces, and inside these square braces, let's say I'd want to extract this element over here. So this element is present at second row, second column of the second matrix, right? So these would be the values. So I will give in the row number, which is 2. I would give in the column number, which is also 2. Then I will give in the matrix number, which is also 2. Right? So we can extract this element like this. Now let's say I would want to extract this element value 8 from this entire array. So this is present at row number 2, column number 4, and matrix number 1. So let me give in the name of the array, which is ARR1. So I will give in the row number, which is 2. Then I will give in the column number, which is 4. Then I will give in the matrix number, which is 1. Right? So we have extracted this element value 8 from this matrix. So this is how we can work with arrays.
Just a quick info, guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now let's continue with the session.
And then we have something known as a factor. So factors are basically objects which are used to categorize the data. So let's take this example over here. So we have a character vector over here, but in this character vector, we have the same element value repeating twice. So we have male, female, female, male. So we have male repeating twice and female repeating twice. So this basically means that we can convert this into a categorical variable. That is, we can convert this into a categorical variable which would have 2 categories. The first category would be male and the second category would be female. So this is where the factor objects come in. So what we'll do is we will take this character object, we will put this character object as a parameter, the as.factor function, and then we can convert this into a categorical variable or a factor variable. So let's go to our studio and work with some factors. So now what I'll do is I'll create a vector once. So that vector would comprise of 3 character elements x, y, and z. And I will repeat those same values 5 times. And to do that, I would require the REP function, which stands for repeat. So inside this repeat function, I am creating a new vector which would comprise of 3 character elements. So the first character element is x, the next character element is y, and the third character element is z. So we have 3 character elements. Now what I'll do is I will be repeating these 3 elements 5 times. So let me hit enter, right? So what you see is x, y, z is being repeated 5 times. So this is once, twice, thrice, 4 times, and 5 times. So now I will store this in a new object and I'll name that object to be my data. Let me check the class of my data. Class of my data. Right, so this is a character. Now, since we already know that this character vector has 3 different categories, right? So let me print in my data again, right? So this character vector has 3 categories which are being repeated again and again. And these 3 categories are x, y, and z. So now, if I wanted to convert this character vector into a categorical variable, all I need to do is use the as.factor function inside this as.factor function, I will pass in the my data variable and I will store it back to my data. Now let me have a glance at this class of my data. So this time we see that this is a factor. Right, now let me print my data. Let's see what is the difference, right? So see that these are all of the elements and the elements have been segregated, right? So we have 3 levels, X, Y, and Z. Okay, so this was how we can create factor objects in R. And then finally, we have a data frame. So data frame is basically a 2-dimensional structure where we can have heterogeneous elements. So here, each column can comprise of only homogeneous elements, while a row can either contain homogeneous or heterogeneous elements. So, and this is the command to create a data frame in R. So we will use the data.frame function, and inside this data.frame function, we can create different columns. So here what we are doing with this command is we are creating 2 new columns. So I am naming the first column as name, and the values which would go in the first column are Sam and Bob. The name of the second column is age, and the values which would go into the second column are 32 and 48, right? And this is the resultant data frame which we get. So we have 2 columns. The first column is name, the second column is age, and the values under name are Sam and Bob, and the values under age are 32 and 48, right? So now let's go to R and create a data frame by ourselves. So now what I'll do is I want to create a data frame which would be comprising of 2 columns. The first column would comprise of names of fruits, and the second column would comprise of the cost of those fruits. So I will use in the data.frame function, and I will name the first column to be fruit name. Now let me assign values to this first column by using the C function. So let's say I want 3 fruits over here. So the first fruit would be mango, the second fruit would be apple, and the third fruit would be banana. So now we have created the first column. After this, we'll go ahead and create the second column. So the second column would be fruit cost. So let's assign some cost to those 3 fruits. So the first cost value would be, let's say, 105. The second cost value would be 57, and the third cost value would be 80. So now I will store this in a new object and name that object to be fruit. Let me have a glance at fruit now. So we can use the view function to have a glance at a data frame. So view of fruit, right? So we have successfully created this data frame which would comprise of these 2 columns. So the first column is the name of the fruit, and the second column is the cost of the fruit. The first column comprises these 3 values, mango, apple, and banana, and the second column comprises these 3 values, 105, 57, and 80, right? So now we'll learn how to extract individual columns from this data frame. So let's say I wanted to extract this fruit cost column from this data frame. So for that, I would have to give in the name of the data frame first, which is fruit. After that, I will use in the dollar symbol, and using that dollar symbol, I will select that column which I want to extract. And since I want to extract this fruit cost column, I will select this. So what I'm basically doing is, from the fruit data frame using the dollar symbol, I am extracting the fruit cost column. So let me hit enter, right? So we have successfully extracted this column from this data frame. Now let's also understand how can we extract individual values from this data frame. So let's say I wanted to extract this value from this data frame. So this value is present at 3rd row, 2nd column. So if I wanted to extract that cell value present at 3rd row, 2nd column, then I'd have to give in the name of the data frame first, which is fruit. I will give in square braces. First, I will give in the row number, which is 3. Then I will give in the column number, which is 2. Let me hit enter. All right. So we have extracted the cell value from this data frame over here. So these were the different objects with which we could work in R. Now let's head on to decision-making statements. So decision-making statements basically help us to impose a condition, and on the basis of that condition, execute some statements. So in general, we basically work with these two decision making statements. So we have if and if else, right? So now let's start with if. So this is how the if statement works. So first we will give in the condition and check if the condition is true or false. So if the condition is true, then the rest of the statements will be executed, else nothing will be done, right? So this is how the if syntax works. So we'll give an if over here, we will give in the condition, and if this condition is evaluated to true, only then some sort of action is done, else nothing happens at all. Okay, so let's go to our studio and work with the if statement. Right, so now what I'll do is I will actually create a new vector and name that vector to be check decision, and inside this vector I will give in 6 numeric values, which would be 10, 20, 30, 40, 50 and 60. Right, so we have our check decision vector ready. Let me hit enter. Right, so we have this vector ready. Now let me use the if statement to find out if the element present over here, the value of the element present over here is greater than 30 or not. And if the value is greater than 30, I will perform some action. So I will type in if over here, then I will give in 2 braces. Inside this, let me give in the condition. So the condition would be check decision, and I am checking if the element value, this value which is present at index number 3. So if the value present at index number 3 of this check decision vector is greater than 30, then I will print out the element present at index 3 has value greater than 30. Now let me select all of this and let me print. Let's see if we get something or not. So guys, we don't get anything, so we don't get a result. So why is it that you think? So this is because this condition has been evaluated to false, right? So the third element was exactly 30. So let me print check decision over here. So this is the first element, second element, and this is the third element in check decision. So over here, the condition is if this element's value is greater than 30, only then we will print this, else nothing will happen. And since 30 is not greater than 30, nothing is happening over here. Right. So now let me make a small alteration over here. So what I'll do is I am checking if the element present in the third index, the value is equal to 30. And if the value is equal to 30, I will print the element present at index 3 has value equal to 30. Let me select this command. Let me paste it over here. Right. So this time, this condition is evaluated to true. So the index which is present at 3 has the value 30. And since this is evaluated true, that is why this statement has been executed and we get the result. The element present at index 3 has value equal to 30. So that was the if statement. Now let's look at the if else statement. So the problem with the if statement was if this condition was evaluated to false, nothing else was happening. So this is where if else statement comes in. So here what we do is we check the condition first, and if that condition is evaluated to true, we do certain set of actions. But if the condition is evaluated to false, we do an alternate set of actions. So we just don't leave it out there, right? If the condition is evaluated to true, we perform first set of actions. If the condition is evaluated to false, we have an alternative set of actions. And this is the syntax for that, right? If condition, this is evaluated to true, then these statements are executed. Else, or in other words, else the condition is false, then the statements below this are executed. Right. So now let's use the if else statement. So now I'll be working with this same check decision vector. So now this time what I'll do is I'll be using the if else clause, and I will check if this value is greater than 30. And if this value is greater than 30, I will print value is greater than 30, else I will print value is not greater than print 30, right? So it's a very simple thing, guys, right? So I am using the if statement over here, and over here I will be using the vector which is check decision, and I am checking if the element 3 of the check decision vector, the value is greater than 30. And if the value is greater than 30, I will be printing value greater than 30. Else I will print value not greater than 30, right? So now let me select all of these and let me paste it over here and let's see what is the result. Right. So we get value not greater than 30. So what has happened over here is, so we have checked the condition, this condition evaluated to false. And since this condition evaluated to false, we will come to this else block over here. So this else block is printing value not greater than 30. Right, so these were some decision making statements. Then we have looping statements. So the looping statements basically help us to iterate a certain task, right? So I'm repeating it again. The looping statements, as the name states, they help us to loop a certain set of actions or iterate or repeat a certain set of actions. And the two most commonly used looping statements are for and while.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So let's start off with the for looping statement. So this is how this works. So we have the syntax over here, for variable in vector, and then these are the statements which are executed. So what we are basically doing is we will extract the first element from the vector, then we will perform certain set of actions, and then we'll check have we reached the last element or not. So if we haven't reached the last element, we'll go back, we'll extract the next element, we'll perform the same set of actions, and then again we'll check if we have reached the last element. And this process goes on till we have reached the last element, right? So let's go to RStudio and implement a for loop. So this time what I'll do is I'll create another vector and I will name that vector to be check loop, and the values which I'm assigning to check loop would be 100, 200, 300, 400, 500 and 600. So let me print check loop over here, right? So we have a vector ready. So now this time using the for loop, what I'll do is I will be adding 50 additional, so I'll be adding additional 50 values to each of these elements, right? So this 100 will be turned into 150, 200 will be turned into 250, 300 to 350, this to 450, this to 550, and this to 650. So let's do that using the for loop. So I will use for, and we automatically have the snippet over here. So first I need to give in the variable name which would parse through the vector. So let's say I name it to be I, and the vector which I need to iterate through would be check loop. So this I would start from index value 1, and this will iterate through the entire vector. And after iterating, what I'm going to do is I'm going to add a value of extra 50 to each of these elements. So print of I plus 50. So let me explain this properly. So what will happen is for I in check loop. So for I in check loop, initially the value of I would be 100. And since the value of I is 100, I am adding another 50 to this, and the result would be 150. Right. So once this is done, I am going back and I'll check if I've reached the last element or not. No, I have not reached the last element. So the next element is 200. So now I'll take in that 200 and I'll add another 50 to it. So the value would be 250. Next, I'll go back and check if I have reached the last element or not. Again, I have not reached the last element. So this time the next element's value is 300. So this time I'll print 300 plus 50, right? So this is how it'll go on till the last element is encountered. So let me select all of this. Let me print it over here. Right. So this is the result. So initially we had 100, 200, 300, 400, 500 and 600. And those values have been changed to 150, 250, 350, 450, 550 and 650 using the for loop. So next we have the while loop. So let's understand how this while loop works. So here first the condition is evaluated, and if the condition turns out to be true, then this certain set of actions are done. And if this condition is evaluated to false, we exit out of the loop. So let's say we keep repeating this till the loop or the condition is evaluated to true, right? So I'm repeating it again, guys. So this condition or the loop will run till the condition is evaluated to false. So as long as the condition is true over here, this loop will continue to go on. Right, so let's implement a while loop over here. So I'll be working on the same check loop vector, and this time what I'll do is I'll add additional 100 to the same elements. So I will use while and I will give in condition over here. So the condition would be while I is less than length of check loop. So now here I will not automatically get a value. So you would actually have to initialize the value of I. So let's say the initial value of I is equal to 1. And let me actually set it to be I is less than or equal to length of check loop, right? And if this as I is less than or equal to length of check loop, what I'll do is I will add additional 100 to this. So print of check loop, I'll use the square braces. I will pass an I over here and I will add additional 100 to each element. Then I would also have to increment the I value with 1. So let me go through this again, right? So initially I am assigning the value of I to be 1. So here what is happening is, so this would actually be 1 is to length of check loop, right? So this would actually, so this would be the same, guys. I is less than or equal to length of check loop, right? So what we are doing is first we are checking if the value of I is less than the length of this. And since there are 6 elements in total, one is obviously less than or equal to this. And since this is less than or equal to this, we will be printing the first element and adding 100 to this. After that, we'll be adding one more to the I value and then check if the I value is less than or equal to the length of the check loop. And this goes on till I value is greater than the length of check loop. So let me select all of this and let me paste it over here. Right. So this is what we get over here. So this is how we can work with the while loop.
So this is the assignment. So we'll start off with the select function from the deployer package. So again, we'll have to select the 5th column and the 15th column. Let's do that. So again, this is very simple. We've already seen this, how to select some columns from the data set. So which is a 5th column, 1, 2, 3, 4, 5 dependents, that is a 5th column. So again, first we'll give in the name of the data frame. Then using the pipe operator, we will connect this data set with the select function, and I am extracting only the 5th column and storing it in customer 5. So view of customer 5, right? So this basically gives us the dependence column from this entire data set. Now similarly, we can also extract the 15th column. I'll just let that be because again, that's very simple and it's redundant, right? So after this, we'd have to extract the column numbers 3, 6, 9, 12, 15, and 18 and store it in customer 3 multiple. All right. So Again, the name of the data set, the pipe operator, the select function, and inside the select function, I'll give in all of the column numbers which I want to select. So 3, 6, 9, 12, 15, and 18. I'll certain customer 3 multiple view of customer 3 multiple, and these are all of the columns that we have just extracted. Right. Now I have to extract all the columns starting from column number 10 to column number 20. So for this, I'd have to just put in a colon over here. So first the name of the data set. So inside select, so it'll be 10 to 20, right? So the first column number, a colon, and then the last column number. So I'll be extracting all the columns starting from column number 10 to column number 20. So C 10 20 view of C underscore 10 20, right? All the columns, and this is what we have. After this, we'd have to extract all the columns which start with the name capital P, right? All the columns which start with capital P. So this is something different. So now inside the select function, we have the starts with attribute. So with the help of the starts with attribute, I can extract a particular pattern. So over here, I'll give in a pattern over here. So I want to extract all those columns which start with the letter P, and I'll store this in customer P view of this, right? So we have extracted all those columns where the column name starts with P. Now similar to starts with, we also have the ends with attribute, and over here we are extracting all those columns which end with S, like this column over here, like this column over here, all right? So we are extracting all those columns which end with S, or the name of the column ends with an S. View of customer, this is S actually, all right. So these are the 5 columns where the column name ends with an S. All right, so these were very simple actually, I believe, just using the select function to select some columns. And then we have the filter function where we can filter out some records on the basis of a condition. So first, we'd have to extract all those customers where the internet service is equal to DSL. Let's do that. So customer churn, pipe operator, and then the filter function, and the condition is internet service is equal to DSL, and I'll store it in customer underscore DSL. View of customer underscore DSL. So let me have a glance at the internet service, right? So we have only those records where the internet service is equal to DSL. So there are 2,421 customers whose internet service is DSL. All right. So after this, we'd have to extract those customers where the contract type is month to month and store it in customer month. Let's do that. So this time the condition is contract is double equal to month to month. That's it, as simple as that. So this is a contract column. So over here, basically we have 3 values, month to month, 1 year and 2 year. And we are supposed to extract only those columns where the contract is equal to month, and we'll store it in customer month, view of customer month, contract column, where is it, right? So there are 3,875 customers whose contract type is of month to month. All right. And then the next question, we are supposed to extract all male senior citizens whose payment method is electronic check and store the result in senior male electronic. So over here, the first condition is gender needs to be equal to male. The second condition is senior citizen value needs to be equal to 1. And the third condition, payment method needs to be equal to electronic check. So let's do that. First, we'll given the name of the data frame, the pipe operator, and then inside the filter function, we have to given the three conditions. So the first condition is gender needs to be equal to male. The second condition is senior citizen needs to be equal to 1. And then the third condition is payment method is equal to electronic check. So basically we are extracting all male senior citizens whose payment method is equal to electronic check. And also return senior male electronic. So view of senior male electronic. So there are 298 senior male citizens whose payment method is electronic check. So any doubt with respect to this command over here? So basically we have given three conditions inside this filter function. Any doubts still here? No? Great. Okay. So after this, we'd have to extract those customers where the tenure is greater than 70 months or their total charges is greater than $8,000. So till now we have used the AND operator. Over here we'll be using the OR operator. So this time the first condition is tenure needs to be greater than 70 or total charges needs to be greater than 8,000. And we'll store this in customer total tenure. View of customer total tenure. Right. So let's have a glance at tenure. So we see that the tenure is greater than 70. Let's have a glance at total charges, right? So now, even though over here, the total charges is not greater than 8,000. So let's actually take, right? So this first cell value over here, even though the total charges is not greater than 8,000, but the tenure is greater than 70. That is why we have this a record over here. Similarly, even though the total charges is not greater than 8,000, but still again the tenure is greater than 70, so that's why we have this record. So it's OR operator. So either this condition has to be true or this condition has to be true, right? So let's head on to the final question on the filter function. So now we have to extract those customers whose contract is of 2 years, payment method is mail check, and the value of churn is equal to yes. Let's do that. So again, three conditions. First condition is the contract needs to be of 2 years. The second condition, payment method is equal to mail check, and third condition, churn is equal to yes, and we'll store this in 2 mail yes. View of 2 mail yes. So this is quite interesting, right? So we have just 3 records or 3 customers where the contract is equal to 2 years, the payment method is equal to mail check, and the churn is equal to yes. Or in other words, there are only 3 customers whose contract is of 2 years, payment method is mail check, and will be churning out to another network. So this was all about the filter function. Right, so let's head on to the next function of the deployer package, which would be sample in, sample frac, and count. So we are supposed to extract 333 random records from the customer churn data frame. Let's do that. Right. So we given the name of the data frame, which is customer churn, and then the sample n function. Basically, again, so this is basically an analogous to the sample function from the base R. So sample n is a part of deployer. So you can consider this to be analogous to the sample function from base R, right? So we want 333 random records from the entire customer churn data set, and I'm storing that into customer 333. View of customer 333. So these are the 333 random records. Similarly, if I want 1000 random records from the entire data frame, I just have to give in 1000 inside this. View of customer 1000. So these are the 1000 random records which I have. Now So after sample n, we have the sample frac function, which helps us to select a random percentage of records from the entire data set. So over here, we are extracting 23% of the total records randomly, right? So we'd have to give in a fractional value 0.23. So this 0.23 basically means that we are randomly can we sample random samples from the first? Okay, so for that you'd have to so I don't think that is possible with the sample n function for this. That wouldn't be possible with the sample n function. All right. So first you would actually have to maybe select the first. Okay, so you'd have to do two steps for this. First would be customer churn. I want all the columns and I want the first 1000 records. So I will store this in customer 1000. Now out of this, I want a random sampling of 333, right? So you'd have to do this in two steps basically. Sample n and then 333. So I'll just do this in 3 view of 3, right? So you would basically have to do this in two steps. So the first step, you'd have to extract the first 1000 records manually, and then you'd have to do the random sampling. Right, so we were working with the sorry for that. Yeah, so as I was saying, we were working with the sample frac function and this. So we are extracting 23% of the records from this entire data set. View of customer 23%. So basically 23% of 7043 comes down to around 1620. So this is random sampling of 23% of the records from the entire customer churn data set. Right, so after this we have the summarize and group by functions. So we will basically not do the first two because again this doesn't mean anything. So we'll do the third, fourth, and fifth. So we'd have to find out the standard deviation of tenure and group it with respect to payment method. Let's do that. So what we are doing is we want to know the standard distribution, the standard deviation of tenure with respect to the different categories of the payment method. So I want to know the standard deviation of tenure with respect to electronic check, the standard deviation of tenure with respect to credit card, standard deviation of tenure with respect to mail check, and so on. So again, first I'll give the name of the data frame and then I will give in the group by function. So first I will group it with respect to the payment method column. So after I group it, then I will summarize. So inside the summarize function, I'll give in the standard deviation of the tenure. So this is what we get. So the standard deviation with respect to bank transfer is 23 months, with respect to credit card as 23.3, with respect to electronic check as 22.4, and with respect to mail check as 21.2. Right. Now you guys need to keep in mind that the sequence should be first the group by function and then the summarize function. So if you interchange these two, then this will not work. So let's say I will do Control X over here and then Control V over here. So now this won't work because we are giving the name of the column later on, right? So this is why this will not work over here. So basically first you would have to group and then you would have to use the summarize function. So this is how basically you can use the group by and summarize functions together. Now, after that, we'd have to find the median of monthly charges with respect to the contract column. Let's also do that. So whereas the contract column, right, so we want the median of this monthly charges with respect to 1 year, with respect to month, and with respect to 2 years. So again, first we'll give the name of the data frame, and then we'll give the group by function, and then we are grouping it with respect to the contract column. After that, inside the summarize function, we will, so we basically want to summarize the median of the monthly charges. Right, so the median monthly charges of those customers whose contract is month to month is around $73. Of those customers whose contract is 1 year, it's around $68. Of those customers whose contract is 2 years, it's around $64. And then finally, we want the variance of total charges with respect to internet service. Let's do that. All right, so I want the variance of monthly charges over here with respect to internet service. Was it? No, so that was variance of total charges with respect to internet service. So let me just change it to total charges over here. And then I need to group it with respect to internet service. All right. So now over here we have NA values because there are already some NA values present in the total charges column. So let's go ahead and remove those NA values. So over here, I just have to put NA.RM equals true. When I do this, those NA values are removed and I get the total charges for DSL, for fiber optic, and when the customer doesn't even have internet service. So this was working with summarize and group by. All right, any doubts till now? Right. So then we are also done with data manipulation. Now it's time to start with data visualization. So we'd have to make bar plots. So the first bar plot is for the phone service column. So let's create a bar plot for the phone service column. Where do we have phone service? Right. So we'd have to create a bar plot for this. And now, so basically bar plots, as you might already know, they are used to understand the distribution of categorical values. So this is how we can create a bar plot. So we'll use the ggplot function, and first we will start off with the data layer. So first the data is customer churn, and then we'll add the aesthetic layer. So we are mapping the phone service column onto the X aesthetic. Now, after we're done with the data layer and the aesthetic layer, we will go ahead to the geometry, which is bar plot. So to make bar plots, we will use the geom bar function. Oh, I actually have to load the package first, library of ggplot2. Only then I can use the ggplot function. Right, so this is the distribution of the phone service column. So we see that majority of the customers, over 6,000 of the customers have phone service. There are like very few customers, like less than 1,000 customers who don't have phone service. So this is the inference which we can draw from this bar plot over here. So now after creating the bar plot, we were also supposed to add a fill color and a boundary color. Let's do that. So now inside the geom bar, I'll just use the fill aesthetic and set the fill aesthetic to be equal to pink. So this is how we can assign a fill color. Now, after assigning the fill color, we were also supposed to add a boundary color. So we can add a boundary color by using the COL aesthetic, and that was supposed to be Peru, right? So we have added a fill color as well as a boundary color to this. Then we are supposed to make a bar plot for the internet service column. Let's do that. So again, data layer customer churn, and then we map the internet service onto the X aesthetic, and then we make a bar plot for this. So this is the distribution of the internet service column. So we see that there are more than 3,000 customers whose internet service is of type fiber optic. There are around, let's say, close to 2,400, maybe 2,400 customers whose internet service is DSL. And then there would be around 1,500 odd customers who don't avail internet service.
Just a quick info, guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So after this, we were supposed to assign the contract column onto the fill aesthetic. Let's do that. Right, so now basically we are not using fill as an attribute, we are using it as an aesthetic. So if you want to use fill as an attribute, we will give this inside geom bar. But if you want to use this as an aesthetic, we will give this inside the aesthetic layer. So basically we are mapping internet service onto the fill aesthetic. So the fill color of these bars would be determined. Oh, so it was actually supposed to be determined by the contract column. So let me change it to be contract. All right, so the fill color should have to be determined by the contract column. So this is how a plot will look. So over here, this pink color is for those customers whose contract is of type month to month. This green color is for those customers whose contract type is of 1 year. And this blue color is for those customers whose contract is of type 2 year. So if we take this first category where the internet service is DSL, then we see that the major proportion is of those customers whose contract is month to month. Similarly, again, those whose internet service is fiber optic, again for them, the contract is majorly month to month. Now, if we take the third case where people don't even avail internet service, then most probably their contract would be of 2 years, right? So there is a greater probability for those customers who don't avail internet service. So their major probability, so their contract for them, the major probability is to be of 2 years.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash. A. Packages. B. Functions. C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Right. So after this, we were supposed to set the position of the bars to identity. Let's see what is the difference over here.
Actually, I have a question.
Yeah, sure.
What is the count on y-axis? What is the count on y-axis?
Count as the number of customers over there.
But in the data set, I think more than 7,000 customers. So why is showing only 3,000?
Because this is the range we have over here. Out of the 7,000, there are 3,000 odd whose internet service is fiber optic. There are 2,000 odd whose internet service is DSL. and there are 1500 odd who don't even avail internet service. So like add this up, 3000 plus
Yeah, got it.
2500 plus 1500. So that comes down to 7000 odd.
Okay, I got it. Okay.
Right. Okay, identity is this. Seems like this is not changing to anything. Okay, great. So, and finally, we are supposed to make a final bar plot for the tech support column. Let's do that. Again, data is customer churn. We are mapping tech support onto the X aesthetic and the geometry is geom bar. So this time, the number of customers who don't avail tech support is very high. So there are around 3,500 customers who don't avail tech support. And these are those customers who just don't even have internet service. So there are 1,500 customers who don't even have internet service. And this value is basically for those customers who have internet service and also avail tech support. So there are around 2,000 customers who have internet service and avail tech support. So this is how we can draw inferences from this bar plot. After that, we were supposed to assign churn onto the fill aesthetic. Let's also do that. So this time the pink color that denotes those customers who will not churn out, and the blue color denotes those customers who will be churning out. So if we take this category DSL, then the proportion of customers who will be not churning out is high. So it is actually the same case for all three bars, right? So the proportion of those customers who will not be churning out is high in these three cases. Right. So that was how to make bar plots, right? So are you clear with making bar plots and adding colors to them, assigning different columns onto the fill aesthetic? Any doubts with respect to this?
No.
Okay. Right, so bar plot, we're done. And then we have to make histogram. So we have to make a histogram for the tenure column. And then we'll have to add the fill color, the boundary color, and change the number of pins. Let's do that. So again, the data is this, and we are mapping tenure onto the X aesthetic. So this time the geometry is histogram. So if we have to make a histogram, we have to use the geom histogram function. And this is the distribution of the tenure column. So if we want to get the distribution of a continuous variable, then we'll go ahead and make histograms. Right, so this you'll have to understand the difference between bar plots and histograms. So bar plots you'll use when you want to understand the distribution of categorical columns, and histograms you'll use when you want to understand the distribution of continuous columns. So this basically states that there are around like 600 odd customers whose tenure is like not even 1 month. They churn out before 1 month. So there is a very high proportion for this. And then again, there is again a high proportion. So there are around like 500 or 550 odd customers whose tenure is around 70 months or something. And if we take this one, so there are around 200 odd customers whose tenure will be around 42 months. So let's take this case. So there would be around 310 odd customers whose tenure would be 10 months. After that, we were supposed to assign a fill color. So we are using fill as an attribute, not as an aesthetic. So that is why we'll use this inside the geom histogram function. And the fill color which we are assigning is medium spring green, right? So this color which you see over here, this is medium spring green. After this, we are also assigning a boundary color by using the COL attribute, and the boundary color is azure. So this is azure. And then finally, we will go ahead and change the number of bins. So this warning which you see, using bins is equal to 30, pick better value with bin width, right? So by default, it just gives us 30 bins. So if you want to change the number of bins, then we can use the bins attribute. So this time I am setting the number of bins to be equal to 100. So when I set the number of bins to be equal to 100, this is what I get. Okay, so this was how we can create histogram for the tenure column. Now, similarly, we'll go ahead and create a histogram for the monthly charges column. So again, data is customer churn. We are mapping monthly charges onto the X aesthetic, and the geometry which we are using is geom histogram. So this is the distribution of the monthly charges. So there is again a very high proportion over here. So this tells us that around 1100 customers whose monthly charges is around $25. Right. So this is the greatest the range. So there are very high customers whose monthly charges is very, very less. So there are 1100 customers whose monthly charges is just around $25. And if we take this case, so there are very few customers, so there would be around maybe 280 or 280 odd customers whose monthly charges are actually greater than 100, and there would be like exactly 300 customers whose monthly charges are $100. So again, if we take this peak, so like close to around 300 customers whose monthly charges would be around maybe 55 or 60 over here. So this is how you can draw inferences from this histogram. Now after this, we are supposed to map the payment method onto the fill aesthetic. Right, so over here, what we've done is we have mapped the payment method onto the fill aesthetic. So this pink color denotes bank transfer, green color denotes credit card, blue color denotes electronic check, and this dark pink or purple, whatever color you call this basically represents the mail check. So again, there is like no purpose to add this color, so this just brings in more chaos. But then again, later we'll see that we have something known as a facet grid. So using facet grid, we can separate each of these categories into separate facets. So that is when the visualization would be even better. All right. Now, after this, what are we doing? So we are setting the position to be equal to identity. Right. So the difference between this and this is basically, so whatever, so let's take this case over here. So the bank transfer. So this bank transfer is the like absolute value of this, right? So the absolute value of bank transfer would be from this to this. So this will be around 200 odd. And this is again the absolute value of credit card, which is around maybe, how much is this? Again, 200 odd. So now what we'll do is we will be basically stacking the absolute values on top of each other, and we'll get only those values. So over here, mailed check has the maximum count. The other values basically go behind this. So the other bins which you saw in the earlier graph, electronic check, credit check, and bank transfer, those bins have been basically stacked behind this, this mail check. So identity basically is, it shows you the true identity. The other values or the other categories go behind this original histogram. So this basically helps you to understand the proportion of those bins which have the maximum values over here. So let's see over here, let's say if the monthly charges is somewhere around $25, then most probably their payment method is mail check. Similarly, if you take this group over here, so this group, if the monthly charges is somewhere between $75 to $100, then the major proportion of customers, their payment method is electronic check. So this is the sort of inference which you can draw from this. Now, similarly, let me also map the online backup column onto the fill aesthetic. Right. So this is what we get over here. Again, these are the absolute values. So let's say if I set the position to be equal to identity over here. So this is the difference. So this is the absolute values. This is when the position is equal to identity, right? So this time, if the monthly charges are around $25, then most probably they don't even have internet service. And if their monthly charges vary from $75 to $100, then they will have internet service and they will also be availing online backup. And similarly, if we take this, so this would be somewhere between $70 and $75. So if it's $70 and $75, then most of the customers have internet service, but they are not availing online backup. Right. So any doubts still here on how we are using this identity position, the difference between this and the previous plot? Okay. So we'll just make the final histogram then. So we'd have to make a histogram for the total charges column. Let's also do that. Control C and then yes. Okay, right. Right. So x-axis, we are mapping the total charges, and I'll actually delete this first and then add it later. Right. So this is a distribution of the total charges column. So we see that the majority of the customers, their total charges is somewhere around, how much would this be? So this will be 1250. So this will be somewhere around $500 maybe, right? So there are very, very few customers. So let's take this. So there would be around 125 odd customers whose total charges are around $5,000. Again, there would be around, let's say, 50 odd customers whose total charges would be greater than $7,500. Now let's also map the gender column onto the fill aesthetic. So fill should be equal to gender. Right. So over here, this pink corresponds to all of the female customers. This blue corresponds to all of the male customers. All right. Again, let me set this to be identity over here. So what this basically means is there is just a greater proportion of male customers in our data set than female customers. We have this totally blue because, again, there is a greater proportion of male customers in our data set than female customers. All right. Now let me map the internet service column onto the fill aesthetic. All right. So we see that we have three colors actually. So let me remove identity first. So we have three colors. Blue is for those customers who don't even have internet service. Green is for those customers who have internet service and their internet service is fiber optic. And pink is for those customers who have internet service and their internet service is equal to DSL. So again, the people who don't have internet service, so their maximum total charges would come to around maybe $1,800 or somewhere like that, right? And there is a greater proportion of those customers who avail either internet service of DSL or fiber optic, right? So this was all about histograms. Now we'll go ahead and make some scatter plots. So we'd have to make a scatter plot between total charges and tenure, and map total charges onto the y-axis and tenure onto the x-axis. Let's do that. So till now, we did, so we had just one column mapped onto the x-axis. So in scatter plot, we'll have one column mapped onto the x-axis and one column mapped onto the y-axis. So this over here is basically total charges versus tenure. Total charges is mapped onto the y-axis and tenure is mapped onto the x-axis. So this is the aesthetic layer. And then if we have to make a scatter plot, we will use the geom point function. So this is basically the distribution with respect to tenure and total charges. So we see that as the tenure of the customer increases, the total charges of the customer would also increase. Now after this, we are supposed to assign color to this. So I am assigning a color of wheat 3 to these points over here. Right, so this color which you see, that is equal to wheat 3. Now I am using COL as an aesthetic, not as an attribute, and I am mapping the payment method column onto the COL aesthetic. I'll hit enter. All right, so again, so this is like very chaotic over here. So we pretty much don't really understand what this is. So again, to make better sense of it, we will have to facet this data with respect to different payment methods. Now I will map the gender column onto the color aesthetic. So again, this really doesn't make sense. We'll have to facet the data. All right. So that was basically between the total charges and tenure. After that, we'd have to make a scatter plot between tenure and monthly charges. Let's also do that. So we are mapping tenure onto the y-axis and monthly charges onto the x-axis, and the geometry is geom point. Now this scatter plot basically tells us that there is no proper relation between monthly charges and tenure. So we basically can't say that if monthly charges increases, tenure also increases, or if tenure decreases, the monthly charges increases. So we can't say if there is any sort of relationship between these two variables. Now, just for fun, let's also add some color to this. So we'll add yellow green to this. I'm using COL as an aesthetic. Sorry, I'm using COL as an attribute, and I'm assigning the color of yellow green. So this color which you see, this is yellow green. After this, I'll map the internet service column onto the COL aesthetic. So this time I am using COL as an aesthetic, and I'm mapping internet service onto the COL aesthetic. Now, when we map the internet service onto the COL aesthetic, so we basically get a sort of a bifurcation. So with this, we understand that. So this blue color is for those customers who don't have internet service. This pink color is for those customers whose internet service is DSL, and this green color is for those customers whose internet service is fiber optic. Now, the inference which we can draw from this is those customers whose monthly charges is like $25 or less than $25, their internet, so they basically don't even have internet service. After that, those customers whose monthly charges are between, let's say, $25 to around $70, then their internet service would be equal to DSL. Similarly, those customers whose internet service, those customers whose monthly charges is between $75 and $100, then most probably they would be availing the fiber optic internet service. All right. And then I'll also map the contract column onto the COL aesthetic. And let's see, what do we get? Well, this is not much clear as compared to the previous plot, isn't it? Right, so again, we'll have to facet this to understand this better. So this was scatter plot. So basically we have mapped one column onto the y-axis and one column onto the x-axis, and we've used the geom point function to make all of these scatter plots. Right, so then we have box plots, and this time we have to make a box plot between tenure and partner column. Right, so now box plots are used where we have to understand the distribution between a categorical column and a numerical column, are basically a continuous variable and a categorical variable. So over here, I am mapping tenure onto the y-axis and partner onto the x-axis. So over here, tenure is my continuous variable and partner is my categorical variable. So this were the aesthetics. So the geometry which I'm using is geom box plot. So geom box plot would basically help me to create some box plots. All right. So this is our box plot. So what we understand is the the median value of the tenure is greater for those customers who have a partner, right? So the median value of those customers. If the So this is for those customers who have a partner. So seems like if the customer has a partner, their tenure value, their median tenure value is somewhere around 50 months. On the other hand, if the customer does not have a partner, then most probably his median tenure value is not even 20 months, right? So this is basically how we can draw inferences from box plots, right? So we'll basically compare the median values. So over here, the median value, if the customer has a partner, then seems like his tenure would be longer. And similarly, if the customer doesn't have a partner, then seems like his tenure will be shorter. So again, after this, let's also add some color to this. So we'll use the fill aesthetic we'll use the fill as an attribute, and we'll map violet to these box plots. So this is violet. Now after this, I'll also add a boundary color, which will be snow 3, right? So this is the boundary color. After that, we'd have to make a second box plot where we have tenure and multiple lines. So tenure is onto the y-axis and multiple lines is onto the x-axis. And let's do that. So this is our box plot. So this time we see that if the customer has multiple lines, then he would have the maximum medium tenure value, right? So if the customer has multiple lines, then his median tenure value would be around 45 months, most probably. And if the customer has, so the customer doesn't even have internet service, then his median tenure value would be somewhere around 30 months. So this is for those customers. So they have multiple lines. They have phone service, but they do not have multiple lines. In that case, their tenure would be somewhere around 18 months or so. Now what we'll do is we'll go ahead and map the partner column onto the fill aesthetic. So this time we basically get 2 box plots for each of these corresponding categories, right? So this pink color denotes those customers who don't have a partner, and blue color denotes those customers who have a partner. So as we saw in the earlier case, those customers who have a partner seems like their tenure value is higher than those customers who don't have a partner, right? So each of these 3 categories, so let's take this category. So this is for, again, those customers who have phone service but do not have multiple lines. So seems like the median tenure value is like very high compared to this. Again, median tenure value very high, median tenure value compared to this very high. Right, and then what do we have? Yeah.
What is the dots on the first box plot? There is multiple dot on first box.
So those are basically the outliers, right? So normally when the customer does not have multiple lines, so basically his median tenure value would be somewhere between 1 month to around 25 months. So this is an aberration actually. So maybe there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 customers whose tenure value is basically an aberration. So normally the customer's value would lie somewhere in this range. So these are basically outliers over here.
Okay, thanks.
Right. Then we are supposed to make a box plot between tenure and contract. Let's do that. So this time tenure is onto the y-axis and contract is onto the x-axis. So again, so these outliers, we have outliers over here, we have outliers over here, right? So let's start with this. So normally if the person's contract is on a 2-year basis, then his median tenure would be greater than 60 months, right? His median tenure is greater than 60 months, and normally the tenure would be somewhere between 70 months to around 50 odd months, right? 50 months to 70 odd months. So these values which you see, these are outliers. So maybe around 10 odd customers who basically 10 odd customers whose tenure is less than maybe 15 odd months, right? These are again outliers. Again, in this case, so what we see is these are totally contrasting values. So if the person has a 2-year contract, then his tenure will be quite high. On the other hand, if the person has a month-to-month contract, then we see that his tenure is quite low over here. So if it is a month-to-month contract, then his median tenure would be somewhere around 12 months or so. So these are again outliers. So there are like only 4 customers whose tenure is greater than 70 months and their contract is month to month. And for this case, so this is like 1 year. So those customers whose contract is 1 year, their median tenure would be somewhere around 40 months.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Now let's map the internet service onto the fill aesthetic. So now what we get is 3 different box plots for the corresponding different internet service, right? So maybe you can have a look at this graph and draw inferences by yourself. All right. So we are also done with box plot, and then we will go ahead and facet our data. Right. So faceting again, so it basically whenever our graph is very chaotic, there are too many data points, there are too many columns mapped onto the same graph, we can use a facet grid to facet all of those data into different groups. So that is basically when we use a facet grid. So over here first we are supposed to build a box plot between tenure and multiple lines and then map the internet service to the fill aesthetic. So let's do that first. So this is our plot over here. Now we see that again, so drawing inferences might be a bit difficult from this. So this is where we will go ahead and facet the data with respect to the internet service column over here, right? So for that, we will have to use the facet grid function. And first we'll give the tilde symbol, and after the tilde symbol, we will give in that particular column on the basis of which we are supposed to facet the data. Right. So this was our original plot after faceting our data. So we have basically faceted the data on the basis of the internet service. So this is one group for the those customers whose internet service is DSL. This is one group for those customers whose internet service is fiber optic, and again this is one group for those customers whose internet service who don't even have internet service, right? So now drawing inferences from this is much easier than the previous plot. So we see that if we take these two cases, so if the internet service is either fiber optic or if the customer doesn't even use internet service, so they so there is like 100% likelihood that they don't have a phone service, right? Now all those customers who don't even have phone service, then all of those customers would belong to this category. So all of those customers would basically have the internet service DSL, right? So this was the first part in visiting a data. After that, we will go ahead and create a scatter plot between total charges and tenure. Let's do that. And we are also mapping the contract column onto the color aesthetic. So again, drawing inferences from this is a bit chaotic. So what I'll do is I will facet this data on the basis of the contract column. So first I'll give the tilde symbol and then I'll facet this data on the basis of this contract column. Right, so this time I have three different facets. First facet is for those customers whose contract is month to month. Second facet is for those customers whose contract is 1 year. And third facet is for those customers whose contract is of 3 years. So again, this is basically much easier to either show it to other people and also to draw inferences from this. Similarly, again, the third was we have to build a histogram for just monthly charges, and then we have to map payment method onto the fill aesthetic. Right, this is done. Again, this is very, very chaotic. So we can facet this into different groups. Right, so now again, this is much more prettier than the previous plot. So we have different facets with respect to each of the different columns. So this is why we basically use faceting to make our graphs more pleasing to witness. So this was all about yeah.
Can we add bins to the same bar plot?
You can. So first you'd have to set this over here, right? So inside this, I will set the number of bins to be equal to 100, right? So we've changed this. So basically the number of bins, you'd have to set this inside this function over here, geom histogram. Now let's say I change this to maybe 1000. Let's see how it looks. Right, so this is how our graph will look when we set the number of bins to be 1000. So is that clear?
Yes.
Great. So this is how we can facet the data, and then finally we'll work with the theme layer. So the theme layer helps us to add themes, as the name basically states it. So first we will go ahead and create a bar plot for the gender column. Right. So what I'm doing is I'm creating a bar plot for the gender column. Now after this, I have something known as the theme layer, right? So till here, the syntax is the same. Now after this, I will add the theme layer on top of this. So inside this theme layer, with the help of this theme layer, I can add a color to this panel. So this, what you see, this is the panel onto which we draw our graphs. So with the help of the panel, we can add a color to this panel, and also this white background which you see, that is known as the entire plot. So with the help of the theme layer, we can add a color to the panel, and we can also add a color to the entire plot. So we will use the panel dot background attribute and set a color to this. So we will just type in panel dot background, and then we have the element rect function. So if we want to modify any of the rectangular objects in the theme, so this plot is a theme. So this plot is a rectangular object. This panel is a rectangular object, right? So if we want to modify any of the rectangular objects, then we will use the element rect function, and we will set it a fill color, which is chartreuse 4. So we have successfully mapped a fill color to the panel over here. Right, till now whatever graphs we saw, we were just creating the graphs, but then again we were not adding themes to the panel and the plot, right? So with the help of the theme layer, we have added a color to the panel. Now similarly, we can also add a color to the plot, to the whole plot. So till here again the command is same. After that I'll add another theme layer and inside that theme layer I'll add a background color to the entire plot, and the color for that would be corn silk 4, right? So I've also added a color to the background plot. So this is how we can add color to the panel and also to the background. All right, so any doubts over here on how we're using the theme layer? All right, so first we have to use this theme function. Yeah, go ahead.
These colors, where do we get, how do we get to know like what are the colors? Because this is not a RGB color or not a, so
Right.
these names are something specific to this ggplot or?
No,
Or
so
for
we have
ours?
the colors, we have the colors function. So just use this command over here and you'll see all of the different colors which are available in R. So I'll just copy this command and paste it over here in the chat. Right. So use this command to have a glance at all of the available colors. Right.
Thank you.
Yeah. So after this, we are supposed to make a scatter plot between tenure and monthly charges and add a title, give a color to the panel, give a color to the plot, and then center align the title. Okay, great. Let's do that. So we are creating a scatter plot between tenure and monthly charges. This is our base plot over here. Now, after creating the base plot, we have the labs function. So with the help of this labs function, I can assign a title, right? So inside this, I will use the title attribute and assign this a title. So the title for this would be tenure versus monthly charges. So this was the initial plot. After that, we have used the labs function on top of this and added a title to this. Now, after adding the title, we will go ahead and add a color to the panel. So again, we'll use the theme function, and inside that we'll use the panel dot background attribute and set the fill color to be coral 2. Right? So this color which you see, this is coral 2. Again, after this, we will also add a color to the plot. So till here, it's the same function. After that, we'll also add another theme layer. This time we will use the plot dot background attribute and assign this a fill color of beige. So this becomes a final plot, right? So this is our scatter plot. This is the color of the panel. This is the color of the plot. And then we were also supposed to center align the title. So till now, whatever we've used, it's element rect, right? So we were supposed to make changes to rectangles. That is why we've used element rect. Now we are supposed to make changes to text. So if you are supposed to make changes to text, then theme layer has a function known as element text. And inside this, we will adjust this. So this is where we can use the hedge just attribute and center align this. So when we give this a value of 0.5, this will be center aligned, and we will also assign this a color of red. And this is our final plot. So initially, this is what we had. After that, we center align this and also gave this title a color of red. Right, so we will follow this on adding the different theme layers on top of this. So ggplot2, the best part of ggplot2, why it is widely used in the industry is you can keep on stacking the layers one on top of the other, right? So like you see over here, this is the initial plot. So we just had the data layer and the aesthetic layer. On top of that, we added the geometry layer. On top of that, we added the labels layer. On top of that, we added another theme layer. And again, we added another theme layer, two more theme layers on top of that, right? So this is basically the advantage of ggplot. You can keep on stacking layers one on top of the other, right?
Just a quick info, guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So, statistical method for making simultaneous comparison between two or more means a statistical method that yield value that can be tested to determine whether a significant relation exists between variables. So essentially here we try to know about the difference of the mean of two or more groups. Like if we want to compare, there would be more and more example. One more example is given. A car company wishes to compare the average petrol consumption of three similar models of a car and six vehicles of each models. So what essentially we are saying that we are considering three different models and six vehicles of each model. So we have altogether 18 cars. Out of those 18 cars, there are three groups, there are three different varieties of cars, and we are using 6 cars from each group. So we are going to compare all three groups together to find out that how is which car is similar to other, or which group is similar to others, or which group is dissimilar to others. So it helps us to find out the the difference between the mean of different groups. Now the question comes, manually we can compute the mean and we can say that the mean of one group is higher than the mean of other group. Yes, that we can do, but essentially when we talk about the difference in mean, we are talking about the statistical significant difference. We are not talking about the overall average difference of the mean. There may be overall difference in the mean exist, but that should not be statistical different. The moment we talk about statistical different, there is certain measurement to compute or to say the difference into the statistical standpoint. So it's not as a overall difference in the mean. We talk about difference considering certain statistical assumptions, certain statistical procedures. Another example is given. A teacher interested in comparing the average percentage mark attained in examination of 5 different subjects and has the mark of the 8 students who all completed each examination. So we have 5 different subjects and we have 8 students. So we want to compute that is there any statistical significant difference between the score obtained by the student. We'll see more and more example. So essentially what ANOVA looks at the way group differ internally versus what difference is between them. So it seems a bit complicated, But essentially, what here we try to do, here we compare each and every group with others, then we try to do a overall comparison, clubbing all groups together. So the process of ANOVA calculations can be explained taking the examples given here, that ANOVA calculates the mean of the each group, then it calculates the mean of all group combined, that is overall mean, then it calculates within each group the total deviation. So here we are talking about the deviation, and deviation is what? It's basically the difference which come across the total deviation of each individual score from the group mean, that is within group variation. So here we talk about overall mean and we talk about within group variation. Then we calculate the deviation of the each group. So overall mean, within group and each group. That's what. So there are three different types of mean computation. One is at the overall level, second is group wise, and then we compute the deviation of the each groups. That's how the deviation is there. For that we'll be using some data set available here, but before that I would like to talk more and more by help of some Excel sheets available with me. Now let's consider we have three different samples: sample A, sample B, and sample C. So in sample A there are 5 values. In sample B as well I have 5 values. In sample C I have 5 values. That is, I am saying that this is the numbers from group A, this is number from group B, and this is number from group C. So in first step what we do, we first compute the mean of each and every group. So this is the mean. Then we try to find out the difference between the mean and the value from each group. So here 2 minus 4 is what the difference is. Here 3 minus 4 is the difference. Here 7 minus 4 is the difference. So here we compute the difference. So this cell computes the difference. Then we square it up. We multiply the difference by the difference itself. So what exactly we are doing? E4 multiply E4. So we are squaring it up. And the moment we square it up for each and every element of group A, we sum it up. So now here total sum is 22 for this group. So for sample A, this is sum of the difference. So we can say this is sum of the difference. Similarly for group B, the value is 10, 8, 5, 7 likewise. So and the mean is 8. We compute the difference. Likewise we square it up and sum it up. For group C we perform the similar task. Now then we add up all differences together, that is 22 plus 18 plus 14. So that is what done here. So we added it up together and the sum is 54. So this is called sum of the squares within group. So this is technically this is called sum of the squares within group. So we need to be careful. We are talking about within group. So there are certain terms which talk about with group. Here we are talking about the within group. This is 54. Now in second step we put all values together. This is of the first group, this is of the second group, and this is of the third group. We put all values together, then we compute the mean. So if you see, this is the mean is 8.33, that is written here. And then we perform the same task, value minus mean, that is 2 minus 8.33, the value is given. 3 minus 8.33, this value is given. Likewise it is going up. So we perform this task for each and every element. then again we square it up. That is minus 6.33 multiply with the minus 6.33. We did for each and every group. And again we sum it up. So my sum is 257.33. The sum is coming here. So this is called the total sum of the squares. So remember, we are using different terms here. In previous case, we call it sum of squares within group. Here we are saying sum of the squares, total sum of the squares. Now, in third step, exactly how is the process? Again, we put all values together. We compute the average, that is mean. This is my first group, wherein average is this. This is my second group, average is given. This is my third group, average is given. Now, this is called X bar. That is the mean of each and every group. Now, here I am saying it the mean of total group. So I am saying it xt bar, that is mean of the total group. Now, so we need to I use different terms so that we understand that how this calculation is going on. So now I'm computing x bar, that is mean, minus x total bar. So exactly what I'm doing, 4 minus 8.33, that is computed here. Likewise, for the second group, I'm computing 8 minus 8.33, that is 0.33 is given here. For the third group, 13 minus 8.33, that is 4.6 is given. So now here I computed difference between two groups, that is overall mean minus individual mean. Then I am squaring it up. So minus 4.33 multiply with minus 4.33. Likewise, we square it up. Then we are multiplying this square up with the total number of observation. So I know in my first group there are 5 observations. So I am multiplying this with 5. So 18.77 multiplied by 5 is 93.88. Likewise, here minus here 0.11 multiplied by 5 is this, 21 multiplied by 5 is this. So this multiplication with the total number of element is there. Then I am summing it up. So the sum is 203. So here sum is given. So all three values are summed together. Now this is called total sum of squares. This is called sum of the squares between group. I'm sorry. This is called sum of the squares within group. So we know that here this is 257. So how the relation is, we computed three values. One is sum of the squares within group, that is 54. Then we computed sum of the total sum of the squares, that is 257. And now this is sum of the squares between group 203. So we can essentially see that 257, that is my second calculation, is sum of my third calculation and my first calculation. So this is sum of these two values. So now I'm moving into more and more calculations. So calculation number 1. Here the value which we computed 203, what exactly we do? We divide this value by the total number of groups minus 1. So in our case there are 3 groups. So we are dividing 203 by 2. Because there are 3 groups, so we need to divide it by number of groups minus 1. So this value is here. In second calculation, whatever sum we obtained from my first calculation, we need to divide it by total number of element minus total number of groups. So there are 15 elements, 5 in each group, and we are dividing it by, and from 15 we subtract 3, there are 3 groups, and the calculated sum of squares in first case is 54. So we are dividing 54 by 12. So this is 4.5 is what my second calculation is. Now here we compute the F ratio. F ratio is essentially the value which comes through calculation 1 divided by the value which comes through calculation 2. So this is called, the F ratio is 22.6. Now this is F value. Now we are going to talk about the degree of freedoms, because essentially we are going to use F table. So for F table calculations we must have degree of freedoms for numerator and denominator. So for numerator, how the degree of freedom is computed, that is total number of groups minus 1, and for the denominators, total number of elements minus number of groups minus 1. So that is what essentially the term we use to divide both the values. So now what exactly we are going to do? We are going to calculate F. We are going to see F value in F table with degree of freedom as 2 and 12. 2 and 12 we calculated here. And here the calculated value at 2 degree of freedoms, 2 and 12 degree of freedoms is 22.6. Let's see into the F table. There is statistical table called F table. In the statistical table, for the F distribution, a value corresponding to 2 and 12 is here, it's given. So for 12 in case of denominator and 2 in case of numerator, the value is 3.89. If we see into the plot, but our calculated value is 22.6. So this is exactly 22.59 something. So this is my calculated value is 22.59, and this is the value which is coming from the table. If I look into the distribution of the table, I can essentially say that no, this value is outside the cutoff value which I am supposed to get by 2 and 12 degree of freedom. So if something comes in outside the cutoff region, that is called a rejection region. That is, here we reject the null hypothesis and we can easily say that no, that there is at least one group in the entire calculation whose mean is significantly different from the others. So that is how the interpretations or how the explanation goes on. So we found that our calculated F value was 22.6 with 2 and 12 degree of freedom, whereas in F distribution table the value for 2 and 12 degree of freedom is 3.89. So we essentially say that no, we are going to reject the null hypothesis, that is at least one of the group from the data is significantly different from the others. So that's what the objective is. Now we are going to look into R, that how exactly this calculation happens.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash: A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So here I have the same data wherein I have 3 groups A, B and C, and essentially all values are same: 237, 26, 237, 26. So I am using the same data. So we have 3 groups, group A, group B and C. The last element of group C is 15, that is 15. So last group of the last element of group C is 15. So this is what I'm going to use the same data, and we'll try to figure out that the computation which we did in Excel, is it exactly the same which is coming into the R. So now I am running summary. Summary help us to get information about each and every variable. So it is saying that there are two variables, one is group and second is score. So in group there are three elements A, B and C, and there are three members, that is three groups are there, and inside each and every group there are five elements, that is five members. We are going to use structure function which give us information about the type of variable. So essentially for ANOVA is run between a categorical and a continuous variable. So categorical is here group A, B and C. So categorical variable in R is called factor. So whenever there is categorical variable, R reads it as a factor. So it is sometimes it is not as default, so we need to make it into the factor. But essentially for ANOVA, your variable must be factor. One variable must be factor and another variable must be continuous. Continuous is a number wherein we can perform certain mathematical calculations like 2, 3, 5, 7, the value comes in. We are using the name function to find out the name of the variables. So it is saying that the name of the variables are groups and score. Now we are going to run ANOVA. So for ANOVA, the function is AOV, and inside that we use the continuous variable, that is the score. With a tilde sign we write group. So we are saying that my score is dependent variable, my score is dependent variable and group is independent variable. So remember, dependent comes first and independent comes second. Why I'm saying dependent and independent, this will be better explained in regression and logistic regression section. But here essentially at this moment I would say that your continuous comes first and then categorical comes second. So that will help us to exactly find the positioning of the continuous and the categorical variable. Then we are saying data is equal to CALC. The CALC data which we created, that is the object which is in my R environment, I am using that CALC. So we need to understand the structure of ANOVA. So here we are creating an object called example, and this object is created by help of a function called AOV, that is ANOVA. Inside that function we are supplying two different arguments. One argument is the variable association, that is which one is continuous variable, which one is categorical variable, and the second argument is the data set, that on which data we are going to use it. So now I run example. So an example object is created in my environment. Now I want to see in detail about the output, the object which I created. For that there is function called summary. So the moment I run summary, I get the entire information about ANOVA. So it is saying that there are two groups and there are 12 elements. So how these elements are? This 12, we saw that how this 12 is calculated. That is total number of elements minus total number of groups minus 1. And we essentially saw the sum of the squares for group is 203. Sum of the squares for the group is 203. Then for the residuals, that is for the individual, it was 54. So for individual it was 54. Then we computed some F value, 22.59. That is 22.59. This is given into So now here we are getting that what all we computed, that is coming exactly the same in our environment. So why I explain Excel spreadsheet? Reason being, it helps us to understand the different steps been computed. So here in R, we get simply the output. But but how is the background, how that computation happens into the background, that is essential to know. So that's the reason that we perform a manual computation as well as we perform a computation using the R functions. Now, here we are getting three asterisk. So three stars is given. It is saying that the groups are at least one group is significantly different from other group. So remember, null hypothesis for ANOVA is there is no statistical significant difference between the groups. That is, the difference in the mean of each group is almost zero. So there is no difference in their mean, or we can say that all means have the similar kind of distribution, wherein the alternative hypothesis says that no, at least one mean is different from others. So here we are rejecting the null hypothesis and we are saying that at least one mean is different from others. So now the question is, which mean is different from the others? We know that there are three groups, A, B and C. Statistical output is saying that at least one group is different from the others. Now the objective is to know that which group is different from the others. For that we have another example. So for that we are going to use some data which is available on some website, and we'll extract those data, and by help of that data we'll run the same ANOVA function. So here there is a data set available on the website. So the location of the path is given, that where exactly this is available. So we are saying that http personalityproject.r.org r datasets, likewise information is given. So from here we are extracting the information and creating an object called data.ex1 by help of a function called read.table. So read.table help us to read these values, and we are specifying the object which is created here. So there are two ways possible. Either we write the entire value which is written inside the balance quotation mark, we simply copy this entire content from here to here and put it here, or we write like this. So first we create an object which is equivalent to these values, and then put that object inside the read.table function, and essentially we say header is equal to true. Header is equal to true means we want to read the value with the variable names. So that's what header is equal to true. So in a spreadsheet, suppose there are usually in spreadsheet the first row is about the variable name. So in that case we need to say header is equal to true. There is some alternate source of data wherein we normally do not get with the headers. So in that case we need not to read data with the headers, but here the essential requirement is to read the data with headers. So that's the reason we are saying header is equal to true. And again we are using the same AOV, that is ANOVA function. So inside that data, the data which we extracted, there is a continuous variable called alertness, and there is a categorical variable called doses. On that we are running ANOVA. So here we are doing the same stuff. We are creating an object using this HTTP option. Then by help of that object we are creating another object called data.exe. So that object is created. If we want to see the structure of the dataset which we created, that is data.exe1, so we can see the structure. So structure says that there are two variables. One is doses, that is factor, and second is alertness, that is integer, that is continuous. If you want to say in detail, so this is the variable. This is exactly the way we saw in previous case. So there are different groups for the doses, and there are different alertness. So this is one is the categorical variable and second is the continuous variable. Now we are running the ANOVA function, that is AOV, considering alertness as it's a continuous and doses as the categorical. So an object called AOV.ex1 is computed. Now we want to see the summary, the way we saw the previous summary, wherein the entire residual, some of the squares, f value, everything comes in. So the moment I run it, it is saying that the probability is 0.0298, and here there is double star. It is saying that we are going to reject the null hypothesis, that is at least one group in the given data is different from the others. So that's what this asterisk, that is star mark, indicates. Even by looking at the probability value, if this value is less than 0.05, so in that case at 95% confidence or at 5% significance, we reject the null hypothesis. So essentially we are doing the same stuff here. We are saying that no, there is at least one mean into the data, that is one group in the data which is statistically different from the others. So that's what the interpretation is. So here we can, by looking at the output, we can say that there are three groups, and essentially this value is 15 is what? This is total number of observations minus total number of groups minus 1, and this is sum of the squares within group, total group, and essentially this is how f value is computed, the way we saw into the previous case. Now the question is, here in the output we got that at least one group is different from the others, but essentially which group is different from the others? For that there is another test called 2k test, 2k. So we run 2k test on AOV.ex1 to get the difference, that which one is exactly different from others. So we are running 2k test here. So now the best part with this test is it prints a group wise comparisons. So it is saying that when we compare group B and group A, we are getting that probability value is 0.2768. That is what, as I mentioned earlier, that if this p value is less than 0.05, so in that case we reject null hypothesis at 95% confidence or at 5% significant and say that both groups are statistically different. But in our case this value is greater than 0.05, so we cannot reject null hypothesis, and we say that no, group B and group A both have the similar kind of distribution, that is we cannot reject null hypothesis in case of group B and group A. Now, so this is called group wise comparisons. In second group comparison, that is C and A, the value is less than 0.05. So here it says that no, group A and C are statistically significant from each other at 95% confidence or at 5% significance. So group C and A are statistically different from others. Now next comparison between group C and B. Again we are getting this value is less than 0.05. So we can say that group C and B are statistically different from each others. That is, we reject the null hypothesis in case of group C and B, and we can say that group C and B are statistically different from each others. So here one thing is very clear, that group A and B are similar, whereas the group C is different from A and B. So we can say that group C is statistically different from group B and group A. Let's see it visually. So that's what we run. So when we run this code, we got the summary output, and on top of that I run QK HSD test to find out the group which is significantly different from others. So in previous case, when we run summary, we got some information about doses, their mean value, their F value, is it significant or not. So we saw the same output coming in our previous case. We are going to inspect manually that how is the mean behavior of each and every group. So now, considering this AOV.ex1, what exactly we're trying to do here? This is my grand mean, that is overall mean. This is mean of group A, this is mean of group B, and this is mean of group C. So we have three different groups, and here we come to know about the mean of each and every group. Now, second option is to get some visual information about the groups. So here we are running the box plot. So box plot for all three groups. So this is for group A, this is for group B, and this is for group C. So here we can say that for group A, the mean is lying, this thick black line is the mean value. So even visually we can see that group C is different from group A and group B. That is what coming in my output as well. So this is what we run. We run the mean of the all three groups, and the moment we run the box plot looks like this, the way we saw. So even box plot is a good way to visually inspect the behavior of the data, the behavior of means, and how values are coming across. Now we are going to talk about two-way analysis of variance, wherein in previous case we had only we had two variables. One was continuous and second was categorical. In this case, we are going to consider multiple variables together. That is, essentially there is one group, and for that group there are multiple variables. So it's not, in previous case it was group and doses. Here we are going to consider, apart from doses, there is one more variable. So we are going to see the impact of different variables on the groups. So is like, suppose I'm giving one example. There is one publication which publish books on math and physics. There is another publication which publish book on math and physics as well. One school use one publications, another school use another publications, and the student of both the schools appear for state level or the national level examination, and now we have a score of the students. We are going to check that is there any kind of statistical significant difference exist between both publishers group. If we we assume that book is the only important factors which contributes into the final score which we get into the examination. Fine. So here assumption is the book is the only factor which affects the score which we get into the examination. Right. So in books we have, so book is one variable, publisher is one variable, and for publisher there is math score, there is physics score. So for publisher 1 there is math score, physics score. Publisher 2 there is math score, physics score. Now we are going to compare publisher 1 and publisher 2 by help of math score and physics score. So in previous case it was only one group and one continuous variable. In this case we have multiple groups and multiple continuous variable. So again we are using some dataset available on the website. So we have gender information, male and female, and we have doses. So different kind of dose was given. So there are two types of dose, A and B, and there are two types of gender, male and female. So for male, dose A and B both was tested. For female, dose A and B both is tested, and for that we have their result. This result, so we are going to compare that how is the impact of doses on different genders when we consider alertness as a continuous variable. So again we run the same function, that is AOV. Alertness is what? It's my continuous variable, and we are using gender and dose. So remember, whenever we have more than two variables, we write like this. So the moment we write like this, we get individual impact as well as the combined impact. Combined impact is what? Gender and doses both together. So we'll get probability value for gender, we'll get probability value for the doses, and at the overall level we get the probability value for gender and doses both together. Let's see that. This is summary of ANOVA, which says that for gender this is the probability. So if I consider gender as standalone, I can say that no, it is not statistically, gender is the impact of gender on alertness is not significantly different. So I cannot say, because this value is greater than 0.05. So we fail to reject null hypothesis. In case of doses, the value is 0.666. Again, this is more than 0.05. So here we fail to reject the null hypothesis. Now, this is called interaction impact. So here, this is interaction of gender and doses. So if both comes together, this is also not significant. So here we can say that no. The output is saying that no, none of the variable is significantly different from the others. So this is how our observation looks like. This is how the data is. When we run the summary, when we run the ANOVA and on the summary, we saw like this, values were coming with certain degree of freedoms and doses. So that all we saw, and I explained that what is the meaning of those all values. Now we are going to print the mean of each and every group, that how exactly mean looks like. It says that the mean for the grand mean is 14.06. The mean for gender female is 16.25, and for male this is 11.88. In terms of doses, if you talk about dose A, the mean is 13.50, and for B it is 14.62. Now, if we try to find out the mean of doses on different combinations, like for female and dosage type is A, so mean is this. For female, dosage type B is this. For male, dosage type A is this. And for female, dosage type B is 12.50. So likewise, this is a kind of cross tabulation wherein we have entire information about each and every cell or each and every component. Now let's plot the box plot. The moment we draw the box plot, we get those entire information. It is saying that this is the mean of A and F, that is type doses A for the female, doses B for the female, dose A for the male, and dose B for the male. So this is how the box plot looks like. So even if I compare the mean of, let's compare with the A and B with female. So these are very close to each others. That's the reason that there is no statistically significant difference was coming across. Even for A and male and B and for male, though the dispersion for the, you can say the range for B and male is quite high, still their mean value are very close to each other. So that's what we are getting here.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. R Studio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session. Just a quick info, guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now let's continue with the session.
You must have heard of data as one of the important and essential resource in 21st century for all the businesses. So the ability to analyze and act on data is increasingly important to business in 21st century, and also keep up with the market, to compete in the market and to adapt the quickly changing demands from the customers. The businesses should be data centric, and the managers of these organizations may need to understand high volumes of data before they make the necessary decisions for the businesses. Also, researchers from the University of Texas found that companies can generate big financial returns by making just small improvements in the data or utilizing more data, improving the data quality, usability, and intelligence, remote accessibility. So it can shoot up the sales of the organization to 14.4% if they increases the usability of its data by 10%. So this shows how important data is. So the importance of data processing can increase the productivity and profits, helps in better decision making, helps in creating more accurate and reliable business strategies to boost revenues. We will be talking about data mining a lot. Using R, we will be implementing a case study. So without wasting any time, let's move on to the why do we need data mining. So I'll give you a real life use case or scenario of food ordering app. So the owner of a online food ordering company realizes that he's facing revenue losses. So he encounters all the factors, he analyzes all the factors on his own, that the application is fine, the customer service is fine, the notification strategy for getting sales is fine, the marketing strategy is fine, the delivery of the food is fine. So where they are lagging in the business. So here comes a data analyst with a lot of data mining techniques to analyze the organizations or the company's data. So he analyzes all the factors and data of customer service, the application, the marketing strategies, the delivery of the food, and the notification system, the cost of the food. So also he analyzes the market and the competitors in the market, their prices, their offers, and comes to a conclusion that the company is not giving offers, a good offers to their customers, and that is the reason that all the customers are going to their competitors and using their application. So the solution to this problem is simple. Give the customers a good offer and they will be yours. And you can get a good revenue generation and you can get a good growth by giving them the offers. So this is the visualization and analysis of the data and the finding of the solution to a problem. So you can understand and you can see from this that how much important is data in real life. Now let's move on to the next part, that is what is actually data mining. So going to the definition, so data mining is simply a process used to turn raw data into useful information. So by using various softwares, the companies can look for patterns in the large batches of data. Then businesses, they can also learn more about their customers to develop more effective marketing strategies, increase their sales and decrease the cost, optimize their products cost so that their customers are willing to buy from them. So data mining is basically the process of extraction of data for business, then collect specific business factors to evaluate the data, such as in this use case that we saw of food ordering app. So the various factors can be the notification system, the marketing strategies, the delivery of the product or the food, and the customer service. So these can be the specific factors for evaluating the business model. Then find useful information from the data, then analyze the data to draw some useful insights and make some decisions to optimize the business strategies. Now let's move on to the next part, that is data mining processes. So these are the processes involved in data mining. That it starts from data extraction, then data pre-processing, data mining, extracting patterns and visualizing data. So we'll start by data extraction. So data extraction is basically extraction of the data from multiple sources in the form of videos, audios, text, image, and it is stored to the databases of the organization. So in the real life, the data is in the form of unstructured. So it is not always structured. It can be found in the form of images, videos, audios, or maybe text. So we need to make it structured for further pre-processing. So the next part is, or the next process is data pre-processing. It consists of cleaning the data, removing the redundancies, and after that removing the missing data, then manipulating the data to understand its variable so that we can understand the relationship and the association between the variables and the data points in the entire data set, and finally transforming data into a readable and understandable format so that machines can understand the data very well and we can work on it so that we can make a predictive model out of it. Now the next one is data mining. So data mining consists of various techniques such as classification, regression, clustering, association rule mining. So the data in various formats, it can be in exe format, CSV format, doc, and various other formats. So it can be, the algorithms are created using the mining techniques such as classification, regression, clustering, and association rule mining. Then the data in the various formats such as you can see in the screen, that is .exe, .csv, doc, xlsx, xls. These data are fed to the data mining techniques or the data mining algorithms to classify the data, make clusters of the data, and apply association rule mining for establishing a relationship or knowing the association between the data. So these data mining algorithms or techniques are used to build a model which, when given a new data set, can predict some outcome. So it is a type of predictive modeling or making a predictive analysis out of the data set. Now the next is extracting patterns. So when the data is fed into the algorithms, it tries to find the relation between the data, tries to extract the patterns from the data so that a useful information can be fetched out of the data that helps businesses to optimize their business strategies, boost revenues, and they can know the glitches in their business. So this is the use of extracting patterns from the data. Now, finally, visualizing the data using beautiful graphs and interactive charts so that we can get statistical overview, a statistical number on what we have visualized and analyzed the data. Now, the next one is the methods of data mining. So we'll be going to understand few of the methods. So these are classification, association rule mining, outlier detection, clustering, and regression. So starting off with classification. So talking about the field of data management, the data classification is a part of information lifecycle management process, and it can be defined as a tool for categorization of data, and it can help organizations to effectively segment their potential customers. So it is the process of sorting and categorizing the data into various types, forms, or any other distinct class. And the data classification enables the separation and classification of data according to the dataset requirements for various businesses, or it can be for personal objectives also. So it is mainly a data management process. So here is an example. A classification algorithm is first fed with the data of cars and bikes, and whenever a new data arrives, such as you can see, if the data of car, if the picture of car is given to the algorithm, then it classifies it as a car, and if the data of bikes or the images of bikes is given to the algorithm, it classifies it as bike. So this is the sole purpose of classification. So data is managed or data is segmented according to various classes, and so whenever a new data set arrives, the algorithm classifies it correctly. After that comes association rule mining. So consider an example that a customer goes to an e-commerce website and looks for a guitar, and he buys a guitar. Then after few months or few days, he also buys a piano, and then he buys a mouth organ. So the recommendation system of the e-commerce website records this sequence of orders and associate it with other orders. So suppose if another customers come and they order a piano or a mouth organ, then the recommendation system will also recommend the products as guitar or mouth organ and all of the musical instruments that are associated with it, so that their sales improves. So this helps these e-commerce websites, and this recommendation engine helps them to increase their revenue generation and to shoot up their sales. Then comes outlier detection. So outlier is the data, or over here you can see a graph that here is a set of regular points and one data point is lying outside the set of common slot of the points. So outlier is basically the data which is not lying in the common slot, and here you can see the graph for number of pens and cost. So from this graph you can see that the cost of 20 pens is close to around 1000 or 500 maybe. So this is the cost of the 20 pens. That means the cost of one pen is either 25 or 50. Now for outlier you can see the number of pens are 30 and the cost is 6000. So 30 pen cost 6000. So the cost of one pen is 300, and it is a large cost as per the common slot of the prices of the pen. So this takes the average cost of the pen a little bit higher from the average cost of the common slot of prices. So this is a redundancy in the output of the data, and it affects the predictive modeling or predictive analytics. So we have to perform outlier detection so that we can use the data effectively to make a predictive model. Now the next one is clustering. So clustering is basically making a group of cluster or segmenting a group of customers according to their similarity. So a common real life example that we can discuss is of Netflix. So what Netflix does is it creates a cluster of similar type of content, and the group of people who are watching type of content, and they make a cluster out of it. They create different groups of people that helps them to recommend the type of content they watch. So this is the application of clustering. So in data mining, this technique helps in analysis of various types of customers. Now the last one is regression. So regression is mainly the evaluation or the comparison of change of one value with respect to another. So here is a graph between x and y that measures or that is showing the data points lying over there, and a linear, you can see this red line that shows a linear relationship between the two. So basically the use of regression is to evaluate or measure the change in one variable with respect to another, to evaluate or to establish a relationship between them. So this is the purpose of regression. So we have understood the methods of data mining. Now we'll move on to the next section.
So what is R? So R is a language developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, R should be a go-to language. Now R is also a great visualization tool. So R provides packages such as ggplot2 and plotly so that you can create stunning visualizations. Now R is an open source, cross-platform compatible software. So it's just plug and play. All you have to do is install R once and then you can start having fun with it. And since R is an open source software, you can actually modify the code and add your own innovations to it. And being cross-platform compatible, you can actually run the same R code on different operating systems. And the best thing about R is it is a Turing complete language. That is, it can perform any task which a Turing machine can. Now that's amazing, isn't it? And this is what makes R such a powerful tool. So you can do various operations such as statistical analysis, implement machine learning algorithms, and also create stunning visualizations, all with the help of this super language called as R.
Installing R. So you can download R from cran.r project. So let's go to the site. Right guys, so this is our archive network, and as you see we have different distributions of R respectively for Linux, Mac and Windows. And since I'm using a Windows system, I'll download it for Windows and I'll click over here, install R for the first time. And guys, this is the latest version of R, 3.5.1. I'll click over here, download R 3.5.1 for Windows. Right, so we get this dialog box over here and I click on run and the download would start. After installing R, we'd also require an IDE to make our tasks easier. So one such IDE is RStudio. And we can download RStudio from rstudio.com. Right guys, so this is rstudio.com. I'll click on download RStudio over here. And this is the free version. I'll click on download. Again, we have different distributions for Ubuntu, Windows, Mac and Fedora. Again, since I'm using a Windows system, I'll install it for Windows. I'll click on run and the download would start. Right, so I've downloaded and installed both R and RStudio. Now let's open RStudio and have a look at the different windows present. Right guys, so this is RStudio and this is how RStudio looks like. So as you can see, RStudio comprises of 4 windows. So this first window which you see over here is the script window. As the name states, you can do all of your scripting over here. So let's say I just type a equals 3 and then I'll type print 3, right? So all of your scripting goes over here. And if I want to, let's say, add a new script over here, I need to click on the plus symbol over here. I'll select R script and we get a new script. Similarly, if I want to add another script, I just need to click over here. Right, we have another new script over here. Oh, okay. And if I want to save what I've written over here, I need to click over here and this will be saved. Let me give this a name. So I'll just give it some random name. I'll save this. Right. So I've saved this file as sgdsd.r. And if you want to run or execute the code, you have this run button over here. So let me select these 2 lines. I'll click on run. So when we click on run, the code goes to the console window and gets executed. So guys, this was the script window. Now we can actually use the console window here directly to run our commands. So I'll give some commands over here. Let me just run some basic mathematical operations. So I'll type 8 plus 5 right? So this gives us 13. Similarly, I'll type 10 minus 5, which gives us 5, right? So you can directly use the console window to run all of our commands. And over here, what we see is the environment window. So this gives us a glance of all the objects we have stored, right? So till now we just have one object with the name A, and that is what we see over here. So we have an object A whose value is 3. Now similarly, let's see if I add another object B over here, B equals 10, and I'll print B. Let me execute these two lines of code, right? So as soon as I executed these two lines of code, what we see is another object has been added in this environment window, right? So initially we just had the object A. After executing these two lines of code, another object B has been added along with its value. And now if I want to clear all of these, I can do that by clicking here, right? So this will remove all of these objects over here. Okay. And then we have the history section. So this gives us a list of all the commands which we have implemented till now, right? So this is just a history of all the commands which we had executed. And we have this final window at the bottom right corner. So this window is for installing new packages, visualizing plots, and accessing help whenever needed. Right, so let me give you guys an example. So let me make a histogram. So I'll type hist. I'll type in lynx, which is a data set. So guys, this is the visualization which we get over here, right? Similarly, if we want to install a new package, I'll click over here. I'll click on install, and let's say the package which I'd want to install would be tree. I'll click here, and when I click on install, the package installation would start. And then we have help. So whenever we need any sort of help, we can use this window. So let's say there is a data set called as iris, which is inbuilt in R. So if you want to know information about this data set, all I need to do is type the name of the data set and I'll hit enter, right? So you get all of the information with respect to this data over here. So guys, this is all about RStudio. So now that we've installed R in RStudio, it's finally time to get on with the practical part. So we'll start off by reading data into R console. R provides different functions to read different data formats. So if you want to read a text file, you can use the read.table function. For comma separated files, you can use read.csv function. For reading JSON files, you have the from JSON function. And similarly, if you want to read data from HTML tables, R provides a function called read HTML table. So you can read all formats of data into R. And since our customer churn data is of .csv type, we'll be using the read.csv function. So let's head on to RStudio. So this is RStudio, guys. So I'll use the read.csv function to read the customer churn data set. All right, I'll put in the double quotes. Now, this is the data set, guys. This is the .csv file. I'll click on properties and I'll copy the path from over here. And I'll paste the path. Now, you need to keep in mind that this is actually a / when you're giving the path, right? And after giving the path, I'll give the name of the file, which will be customerchurn.csv, and I will store this in a new object, and I'll name the object to be customer churn as well, right? So this, what you see, is actually an assignment operator. So I'm reading this path and I'm saving this file into an object called as customer churn. Right. Now let me have a glance at this data set. So what I'll do is I'll use the view function. So I'll type view and I'll type out customer churn. So this is our customer churn data set, guys. Now let me use the class function to have a look at the type of this object. So I'll use class and I'll give the name of the object, which is customer churn. So what we see is this object is of type data frame. That is, this is actually a data frame. Now, if you're coming from the SQL background, you can say that a data frame is actually sort of a table. So over here, all of these columns are of the same data type, and each row represents a record of this data frame. Right. So let's say if I select this column tenure, then this will be of one particular data type. So let me go ahead and see what is the type of this. So I'll use class and I'll type customer churn $tenure. So I see that this is of integer type. That is, this tenure column is of integer type. Now, another thing that you need to keep in mind is all of these columns are actually vectors and factors. That is, a vector is a set of homogeneous entities, and a factor represents categorical values. So now let me type out class, and what I'll do is I'll type out customer churn $gender. So I get that the class of this object is factor. Now, what we see over here is this just has two categorical values, female and male. So whenever we have just categorical values, then most probably the class of that column is of factor, right? So we've understood what a data frame is, and we've also had a look at vectors and factors. Right now, we'll go ahead and understand how can we access individual columns from this data frame or access individual elements from this data frame. Now, let's say I would want to access the column device protection from this entire data frame. So how can I do that? Well, it's actually simple. So what I'll do is I'll start off by giving the name of the data frame. It should be customer churn. Then I'll use the dollar symbol, and I automatically get a list of all of the columns. And since I need the device protection, I will type DEVI. I'll select this, and I'll store this in a new object, and I'll name this new object as C underscore device protection. Right, so let me have a glance at this actually. So I'll type view of C underscore device protection. So what I've basically done is from this entire data set, I've just selected this column and stored it into a new object and named that object as C device protection. Right, so similarly, if I want to select the payment method column, I can do the same thing. So what I'll do is I'll type out the name of the data frame. I'll use the dollar symbol, and I'll type the name of the column, which will be payment method over here. And I'll store this in, let's say, C payment. Now let me have a glance at this. So I'll type view C underscore payment. Right, so I have separated this column from this entire data set. Right, so this is one way by which we can select individual columns. We can also use the second method. So the second method is also simple. So what we'll do is we'll start off by giving the name of the data set, and I'll give the square braces. Now inside the square braces, the values which are on the left side of the comma represent all of the rows, and the values which are on the right side of the comma represent all of the columns. Now let's say I would want to select this gender column. So what I'll do is I'll just give the numbering of the column, that is at which position the column is present. So I'll type out 2 over here, and I'll save this in, let's say, C underscore gender. Now let me have a look at this. So I'll type view C underscore gender. Right, so I have used the square braces to select the second column from this customer churn dataset. Now similarly, if I want to select the first column, I can do the same thing. So what I'll do is I'll just put 1 over here, and I'll name this object as C underscore ID. Right, so let's have a look at this view of C underscore ID. This is the column which gives me the customer IDs. Right. Now we can also select multiple columns in the same way. So let's say I would want to select the second, sixth, and seventh column from the customer churn dataset. So what I'll do is I'll put a comma over here. I'll use the combine function. Right, and I'll give all of the columns that I want to select. So I need the second column, the sixth column, and the seventh column. Right, and I'll store this in C underscore 267. So let's see what is the result now. Again, I'll type view of C underscore 2, 6, and 7. Right, so I have successfully selected second column, sixth column, and seventh column. So let's actually verify. So yes, this is the second column, 3, 4, 5, 6. So 6 is tenure, 7 is phone service. Right, so we have sixth and the seventh column. So this is how we can separate out some specific columns from the data set. Let's say I would want these two columns over here. So I can actually type out the names of those columns. So what I'll do is I'll type monthly charges and I'll save this in C month. So let me have a look at this view of C month. Right, so I have successfully selected out the monthly charges column. Now I can also select a set of continuous columns. So let's go and do that. Now let's say I would want to select all of the columns from senior citizen to multiple lines. That is from column number 3 to 4, 5, 6, 7 and 8. So I would want all of the columns from column number 3 to column number 8. So let's go ahead and do that now. So for that, what I'll do is I'll type the name of the data set. I'll put a comma over here. I'll put 3 and from 3 I'll use colon symbol. I'll just put out 8 over here. So this will give me all of the columns starting from the 3rd column to the 8th column. So let's say I will save this in C underscore 38. So let me have a look at this now. View of C underscore 38. Right. So I have successfully selected out all of the columns from 3rd to 8th. So the 3rd column is senior citizen and the 8th column is multiple lines. Right now, so this is how we can filter out some specific columns. So if we wanted to filter out some specific rows, so let's go ahead and understand how can we do that. Now, as I've already stated, if you would want to filter out rows, we would want to give it on the left side of the comma. And if you would want to filter out some specific columns, you would want to give it on the right side of the comma. So let's go ahead and filter out some rows. So now let's say I would want the second row of this data set. So all I need to do is type in 2 over here and this will give me the second row. Right, so let me store it in C underscore and let me have a look at this view of C underscore 2. Right, so this is the second record whose customer ID is 5575. So let me just verify. Right, so this is the second record over here and this is the same record that we have successfully filtered out. Similarly, let's say if I would want the record or the row number 100. So I'll just type out 100 over here and let me store this in C underscore 100. Let me have a look at the result. View of C underscore 100. Alright, so this is the record which is placed at the 100th row, whose customer ID is this. Now we'll go ahead and understand how can we filter out multiple rows from this. So let's say I would want the 1st, 5th and the 10th row. So I'll use the combine function over here and I'll give all of the row numbers. So I need the 1st row, 5th row and the 10th row. And I'll store this in let's say 1 underscore 5 underscore 10. Alright, so let me have a glance at this. I'll type C underscore 1 underscore and this. Right. So I have successfully filtered out the 1st, 5th and the 10th row. So see that the gender of the customers at 1st and 5th columns is female and the gender at the 10th column is male. Now what we'll do is we'll filter out a sequence of rows. So let's say I would want all the rows from let's say row number 100 to row number 200. So what I'll do is I'll type 100 to 200 and I'll store this in C 100 200. So let me have a glance at this. I'll type view of C underscore 100 200. Right, so this gives me 101 entries.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Starting from row number 100 to row number 200. Right. Similarly, let's say if I would want all of the rows from 10,000. So similarly, let's say if I would want all of the rows from 5,000 to 7,000, we can also do that. I'll just simply put over here 5,000 and then I'll type in 7,000 over here. Right. So let me just type out 5,000, 7,000 over here. Let me have a glance at this. So I'll type view of C underscore 5,000, 7,000. Right, so there are 2001 entries starting from row number 5,000 to row number 7,000. Right. Now what we'll do is we'll give out both the row numbers and the column numbers. That is, we'll filter out some specific rows and some specific columns. So let's go ahead and do that. Now let's say I would want the row numbers from 50 to 60 and I would want just the second and the third column. So let's go ahead and do that. So the row numbers from 50 to 60 and just the second and third column. So I'll use C2, 3. And let's just store in C random 1. Let me have a glance at this view of C underscore random 1. Right, so this gives me all of the records from row number 50 to row number 60, and I've just selected these two columns, gender and senior citizen. Now let me actually go ahead and complicate this a bit. So let's say I would want row numbers from 100 to 200 and also from 1000 to 2000, and I would want the columns 2, 3, 5 and 7. So let's go ahead and do that now. Right, so I'll use C over here. First part would be where I need row numbers 100 to 200, and I would also need row numbers from 1000 to 2000. Right, so this is my first part where I'm filtering out all of the rows, and I would need column numbers 2, 3, 5 and 7. So let me go ahead and put down all of these column numbers, and let me store this in C underscore random 2. So let me have a look at this view of C underscore random 2. Alright, so I have 1102 entries in total, where I have rows from 100 to 200, and as you see over here, just after row number 200, the row number gets to 1000 because I have filtered out all of the rows from 100 to 200, and then it starts from 1000 to 2000, and I've selected column number 2, 3, 5 and 7. Right. So this was an intro to our data frames, vectors and factors, and how can we access individual elements from the data frame. We're going to look at the various types of operators in R and implement them on the customer churn dataset. So broadly speaking, these are the operators. We have assignment operators, arithmetic operators, logical operators, and relational operators. So let's go to RStudio and work with all of these. So we are back to RStudio, guys. So now to work with assignment operators, what I'll do is I'll start off by loading the customer churn dataset, and I'll use the read.csv function for this. I'll put in double quotes and let me go ahead and copy the path of this dataset. So this is the dataset. I'll go to properties and copy the path. I'll paste it over here. Again, this needs to be a forward slash. So I'll change this backward slash to a forward slash. And I'll go ahead and give the name of the dataset, which will be customer churn.csv. Now what we'll do is we'll give an assignment operator. So this symbol which you see over here is nothing but an assignment operator, which helps us to store values into an object. So using this assignment operator, I'll store this customer churn.csv file into an object, and I'll name that object to be, let's say, churn1. Now similarly, there are two other ways by which we can use this assignment operator. So I'll copy this. I'll just clear this window first. Right. And now I can actually give the name of the object first and then use this assignment operator. Right, so this is less than symbol hyphen. It's the same thing. So I am basically loading this path into this object using this assignment operator. Right, so let me have a glance at this. I will type view of churn2. Right, so we have our data set now. Now, instead of using these two operators, I can also use the equal to operator. So I will change this to churn3 now. And when I have a glance at this, this will actually be the same. So churn1, churn2 and churn3 are actually the same data sets, but I've just used different assignment operators to store them into these objects. Right, so these were the different assignment operators. Now we'll go ahead and work with arithmetic operators as well. So arithmetic operators simply are plus, minus, division and multiplication. So now we'll be implementing all of those arithmetic operators on top of this customer churn dataset. So you see these two columns over here, monthly charges and total charges. So I will be using the arithmetic operators on top of this. So I will take this cell over here. So let's say this customer's monthly charges is 29, but actually what happened was there was some calculation error and his monthly charges was just 28.85. So we'll go ahead and change this value to 28.85. So how can we do that? So for that, all we have to do is subtract this cell value with 1. So let's do that. So I will select churn1 dollar and I'll select the column name which is monthly charges. Since this is the cell which is the first row, I will give out 1 over here. So from this cell value, I need to subtract 1. Right, I have subtracted 1. Now I'll store this result back to the same cell. So I'll type churn1 dollar monthly charges and the cell is obviously 1. Now let me have a glance at churn1 dataset. Let me go to the monthly charges column. Right, so here is the difference. So initially the value was 29.85. We have rectified the error, we have subtracted 1 from it, and now the value is 28.85. So similarly, we will be using the plus operator. So plus operator basically helps us to add something to the predefined value. Again, so let's see the second customer over here whose charges are 1889, but again this was incorrectly calculated and his charges were 1890. So we'll just add that 1 to this using the plus operator. So let me select that cell. I'll type churn1 dollar total charges and the cell number is 2 and I'll add 1 to that. After adding 1, I'll store it back to the same result. So I'll type churn1 dollar total charges and the cell number is obviously 2. So let me refresh this. View of churn1. Let me go to the total charges column. Right, so initially it was 1889.50. After adding 1 to it, the total charges became to 1890. Now let's say there is some discount going on and randomly a customer gets a discount of 10%. So let's see it is this customer over here who gets a discount of 10%. So let me see which row number is this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is row number 9 over here. And let's say this customer gets a discount of 10%. So what we have to do is basically multiply this value with 0.9. And when you multiply with value with 0.9, the value gets reduced by 10%. So let's go ahead and do that. I'll type churn1 dollar total charges and it is the 9th cell over here. I will multiply this with 0.9 and I'll store it back to the same cell over here. So this will be churn1 dollar total charges and I've given the cell number over here. Right, let me press enter and let me see what is the result. So view of churn1. So let me go to total charges over here. Right, so initially it was 3046 and after giving a discount of 10%, that total charges came down to 2741. Right, so let me show it again. So it was initially 3046, and after discount of 10%, it was 2741. Now, similarly, let's say a customer gets a discount of 50%. So all you have to do is divide that value by 2. So let's say it is this third customer over here who gets a discount of 50% on his monthly charges. So let's go ahead and divide that cell value by 2. I need to select shown one monthly charges, and cell number is 3. I will divide that value by 2, and I'll store it back to the same cell. So that will be shown $1 monthly charges, and cell number is obviously 3. So let me refresh this now. View of shown 1. Right, so initially the monthly charges were 53 over here, and after giving a discount of 50%, his monthly charges came down to 26. So from 53 to 26, a discount of 50%. Right, so these were arithmetic operators. Now we'll go ahead and work with relational operators. So relational operators basically help us to find out the relation between them, such as which one is greater, which one is lesser. So now let's say I would want to find out all of those customers whose tenure is more than 60. So let's go ahead and do that. So for that I will type shown $1. I'll select the column which is tenure, and I'll just use the greater than operator. That is shown $1 tenure is greater than 60, and I'll store this in, let's say, C tenure. Right, so let me have a glance at this now. View of C tenure. Now these are just false and true values. So what basically this means is, so wherever you see false, this means that the tenure is not greater than 60, and you see this true value, it means that the tenure is greater than 60. So let's actually verify this. So this is the tenure over here. So we see that this is the only value where tenure is greater than 60, and we have a true value for that. Right. So now if we actually want to clearly see the values wherever the tenure is greater than 60, we can use the subset function for that. So I'll use subset. I'll give the name of the data set first. Right. So from this data set, I need all of those values where C of tenure is equal to true, and I'll store this back to C of tenure. Now let me see what is the result. Right, so we see there are 1407 customers whose tenure is more than 60. So you see this over here. So these are all of the customers whose tenure is more than 60, and we found that out using the greater than operator. Right, now similarly we'll use the less than operator to find out all of those customers whose monthly charges are less than $10. Right, so I will type shown $1 monthly charges, and this needs to be less than 10, and I'll store this in C MON. Right, so let me have a glance at this. C underscore MON. And now let me use the subset function to find out the actual values. So I'll type subset, I'll give the name of the data set, I'll type out CMON over here, and I need all of those values where this is true.
Just a quick info, guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now let's continue with the session.
Right. I'll store this back to CM of n. Now let me have a glance at this. C underscore M of n. So see that there are 0 entries. That is, there is actually no customer whose monthly charges are less than $10. Right, so this was the greater than operator and less than operator. Now we'll go ahead and also work with logical operators. So logical operators are basically and or. So these basically help us to give multiple conditions. So let's say I would want to select all of those customers where gender is male and senior citizen is 1. So we can do that using the AND operator. So what I'll do is I will type chown1 dollar gender and I'll keep this to be male. Now I'll use the AND logical operator. Now I will need to select all the senior citizens. That is where chown1 dollar senior citizen is double equal to 1. Right. And I will store this in, let's say, C underscore MS. So let me have a look at this. So I'll type view C underscore MS. Now let me use the subset function to find out the real results. Subset chown1 C underscore MS is double equal to true. And I will store this back to C underscore MS. Now let me have a glance at this. Right, so there are 574 entries or 574 customers whose gender is male and who are senior citizens. Or in other words, there are 574 senior male citizens. Right, so this was the AND operator. Now we'll go ahead and work with OR operator. So let's say I would want to select all of those customers whose internet service is either DSL or fiber optic. So let's use the OR operator for that. So what I'll do is I'll type chown1 dollar internet service is either equal to DSL. Then I'll use the OR logical operator. I'll type chown1 dollar internet service equals fiber optic. That is, I will get the list of all those customers who use either of these internet service. And I'll store this in, let's say, C underscore internet. Alright, so let me have a glance at this. I'll type C underscore internet. Now let me use the subset function to find out the result. I'll give the dataset name, then I'll type C underscore internet and find out all of those values where the result is true, and I'll store it back to C underscore internet. Right, so I see that there are 5,517 customers whose internet service is either DSL or fiber optic. So we are done with the OR operator and operator. Now we'll also go ahead and work with NOT operator. NOT operator basically gives us the contrasting value. So let's see, we'll work with the senior citizen column, and I would want to select all of those rows where the senior citizen value is 0. So you can use the NOT operator for that. So what I'll do is chown1 dollar senior citizen is not equal to 1. That is, so I will get all of those values where this value is not equal to 1. And since the only other value is 0, so I'll get all of those rows. And I'll store this in, and let's say C not senior. And let me have a glance at this. Right. So let me use the subset function, subset of chown1, and I'll give this to be double equal to true, and I'll store it back to C not senior. Let me have a glance at this again. View of C underscore. Right. So there are 5,901 customers who are not senior citizens. Right. So we've worked with assignment operators, arithmetic operators, relational operators, and logical operators. We're going to look at the various types of inbuilt function in R and implement them on the customer chown dataset. So these are some of the inbuilt functions. So let's go to RStudio and work with them. So we'll head back to RStudio. Let me just have a glance at the dataset first. So I'll type out view of customer chown. Right, so this is a dataset. So we'll start off by understanding the structure of this dataset. So for that, I'll be using the structure function str and I'll give in the name of the data set, which is customer churn. Right, so this function gives me the entire structure of this data set. So this basically tells me that I'm working with a data set where there are 7,043 observations of 21 variables. Or in other words, there are 7,043 rows and 21 columns. And these are all of the columns over here. So we have customer ID, gender, senior citizen, online backup, streaming movies, churn, and so on. Right, so now followed by the name of the column, we also have the data type or the class of the column. Right, so over here we see that customer ID is of type factor, gender again is of type factor, senior citizen is of integer, and these are the values. So the values are either zeros and ones, right? And over here multiple lines is of type factor with 3 levels. So these are the 3 factor levels over here. So it could be either no, yes, or no phone service. And then similarly we have the internet service with the 3 factor levels. So it could either be DSL, fiber optic, or no. Right, again, so for contract we have 3 factor levels, which could be either month to month or 1 year or 2 years. Right, so we have found out all of this with the help of the structure function. All right, now we'll go ahead and implement the second inbuilt function. So we'll be using the head function for this. Right, so head function basically gives us the top 6 records of the data set. Right, so I will just go ahead and give the name of the data set over here, head of customer churn. Right, so this has given me the first 6 records. So we have the first 6 records for all of the columns over here. All right, now if I want to have a look at the first 10 records, all I'd have to do is give a number over here. So now I have the first 10 records of the data set. So similarly, if I just want to have a look at the first 2 records, I'll just give the number 2 over here. Right, so I can have a look at the first 2 records of the data set. So similar to head, we have another function called tail. So tail function gives the last 6 records of the data set. So I'll go ahead and give our customer churn data set over here. So you can see the row numbers over here. So they start from 7,038 and they end at 7,043. So basically this tail function gives us the last 6 records of the data set. Now similarly, if I just want the last 1 record of this data set, I'll just give the number 1. Right, so this is our last record. So row number 7,043. Similarly, if we want the last 10 records, I'll put 10 over here. Right, so it starts from 7,034 to 7,043. So these are the last 10 records of the data set. Right, so we are done with head, we're done with tail. Now we'll use nRow and ncol to find out the number of rows and number of columns. Right, so I'll type nRow and I'll give in the name of the data set. Right, so with this we find out that there are 7,043 rows in this column. Similarly, I will type ncol and I'll give the name of the data set customer churn. Now we find out that there are 21 columns in this data set. Right, so now we have some numerical columns in our data set. So we have monthly charges and total charges. Now what if I would want to find out the mean values or the maximum values of monthly charges? So let's go ahead and do that. So let's say I would want to find out the mean of monthly charges. So all I need to do is type out mean over here and then give the column over here. So I'll type customer churn $. I'll select the column which is monthly charges. Right. So the mean of monthly charges for all of the customers is around $64. Similarly, if I'd want to find out the minimum of monthly charges, I'll type out min. I'll give the name of the data set and then I'll type out monthly charges again over here. Right, so the minimum monthly charges are $18. Similarly, if I want to find out the maximum of monthly charges, I'll type out max. I'll give the name of the data set, which is customer churn, followed by the name of the column, which is monthly charges. Right, so the maximum is $118. So similarly, what I'll do is I'll find out the mean, max, and min for the total charges as well. Now we also have the range function, which automatically gives us the minimum and maximum values. So I'll give range over here. I'll type the name of the data set, which is customer churn, and I'll select the column which is monthly charges. Right, so range gives me the range of all of the values. So the minimum value is 18 and the maximum value is 118. Now, let's say there's a lucky draw going on, and we are selecting 5 customers randomly to give a discount. So we can use a sample function for that. So with the help of sample function, I'll be selecting some 5 random customer IDs. So let me go ahead and do that. I'll type sample, and what I'll do is I'll select the customer ID column and I'll give the number 5. That is, from the entire data set, we are selecting 5 random customer IDs. Right, so these values which we see over here, so these are the customer IDs. So this is the first, second, third, fourth, and fifth. So this has randomly given us 5 customer IDs from around 7,043 entries. So again, let's say if I would want around 20 random customer IDs, I'll give the number to be 20 over here. Right, so these are all the 20 customer IDs. Now, next, if you would want to find out the distribution of some categorical variables, then we can use the table function. So over here, we see that we have a lot of factors over here. So gender is a factor column, partner is a factor column, internet service is a factor column. So most of these are actually factor columns. So now if we have a lot of factor columns, we can use a table function to find out the distribution. So now let's say for this gender column, I would want to find out the number of female customers and also the number of male customers. So all I'd have to do is use a table function for this. So I'll type out table, I'll give the name of the data set, and I'll just select the column over here, which is gender. Right. So this basically tells me that there are around 3,488 female customers and 3,555 male customers. Right. So similarly, if I want to find out the distribution for internet service, I'll use the table function again. I'll give the name of the data set, and then I'll give the column name, which is internet service. Right, so around 2,421 customers use DSL and 3,096 customers use fiber optic, and there are around 1,526 customers who don't use any sort of internet service. Right, now, so let's say we would want to find out the contract of the customers. I'll again use a table function and I'll type the name of the data set followed by the column.
Just a quick info, guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Right, so there are 3,875 customers who have month-to-month contract, 1,473 customers who have a contract on yearly basis, 1,695 customers who have the contract on a 2-year basis. Right, so next, finally, we'll use a table function on the payment method column. Again, I'll type a table over here. Right, I'll give the name of the data set, which is customer churn, and I'll select the payment method column. Right, so around 1,544 customers do it via bank transfer, 1,522 customers paid by credit card, and these are the rest of the customers who pay via electronic check and mail check. We're going to work with flow control statements and user-defined functions. Now, these flow control statements basically help us to control the flow of execution. So in general, the statements are executed from top to bottom. But with the help of flow control statements, we can manipulate the order of execution. So these are some of the flow control statements over here. If else, and switch are something known as selector statements. Then we have repeat, for, and while, which are looping statements. We also have some jump statements like continue and break. So let's have a closer look at selector statements. As the name suggests, The selector statements help us to select or manipulate data on the basis of a condition, such as if it rains, will not play football, or if you're sick, you'll not eat ice cream. So we'll just go ahead and start working with the selector statements. Right, so I'll start off and have a quick glance at our customer churn dataset. I will type view of customer churn, and we have our dataset right in front of us. Now I will start with the if condition, and I will check if this cell over here, the value in this cell is female, and if the test condition comes out to be true, then I'll change this value to be male. So let me go ahead and do that. Right, so I will type if, I will give the name of the dataset, which is customer churn, and the column is gender, and the row number is obviously 1. So from this dataset, I am checking if the value in this column is female. So if this is equal to female, then I will give some action over here. So what I'll do is I'll change that value to be male. I'll give the name of the dataset. I will select the column, and in this column, right, so this is cell number 1, and over here I'll change the value from female to male. Right, so initially we had female over here. Now let me copy and paste it over here. Now let me have a glance at the customer dataset again. Right, so we have changed this value from female to male with the help of the if condition. Right, similarly we'll use the if clause again to check if the tenure over here, so we'll take this cell value over here. So if the tenure is, let's say, greater than 62 months, then what I'll do is I'll give this customer a discount of 10%, right? So over here I see the monthly charges, and over here we have the customer. So this is customer who is present at row number 10, and I will give this guy a discount of 10% for his monthly charges. Right, so let me go ahead and create another if clause over here. So I will type if customer churn dollar tenure is greater than 50, and this cell number over here is 10. Now this is very important, right? So this is cell number 10. If that value is greater than 50, then what I'll do is I will give a corresponding discount in monthly charges. Cell number is 10. So customer churn dollar monthly charges, cell number 10, and I will give this guy a discount of 10%. And that is why I am multiplying this value with 0.9 over here. So you see, we have taken out this cell value, and I'm multiplying that value with 0.9, and that is how this guy will get a discount of 10%, and I am storing back the result into the same cell. Let me copy it and paste it over here. So let's just have a quick glance. So the initial value is 56. Now after modification, let's have a look at the monthly charges. Right, so initially it was 56. Then after using the if clause, we have changed his monthly charges to 50 by giving him a discount of 10%. Right, so this was if. Now we'll go ahead and also implement the if else clause. So we'll use the churn column for that, and we'll be using this cell. So let's say if we'll just check if the value over here is no, or in other words, it basically means that the customer will not churn out, or the customer will be using the same network, then we'll just print that thank you for using our network. And if this is yes, then we will print please give us a feedback on how we can improve our network. So let's go ahead and do that. Right, so if customer churn dollar churn, and this is row number 1, is double equal to yes, and if this comes out to be true, I just need to print, please give us feedback on how we can improve our network. Right. Else I will print, thank you for using our network. Let me paste it over here and let me see what will be the result. So we get thank you for using our network because this customer does not churn out. Right, so we are done with if, we are done with if else. Now we'll work with the third selector statement, which is switch. So with the help of switch, I will give this guy a discount on monthly charges with respect to the internet service. Let's say I will take this customer and I will say if this guy uses internet service of DSL, then I'll be giving him a discount of 10%. And if he uses internet service of fiber optic, then I'll be giving him a discount of 20%. So let me go ahead and do this using the switch statement. So I'll delete all of this. I will type switch over here. So over here I need to give the object. So object again. Now since this is actually a factor, I will change this to a character vector. So I will type as dot character of, and I'll give the column over here, which will be customer churn dollar internet service. Right. Now the first case would be DSL. Whereas if the customer's internet service is DSL, then I will give this guy a discount of 10%. Right, again, so let me have a glance at the cell numbers. This will be 1, 2, 3, 4, and 5. Right, so over here, let me just give down the cell number, which is 5. So what I'll do is I'll select customer churn dollar monthly charges, cell number is 5, and I'll give this guy a discount of 10%. I'll give a comma. Now I'll give the second case, and the second case is if this guy uses fiber optic. So if this guy uses fiber optic, then I will give this guy a discount of 20%. So customer churn dollar monthly charges, cell number 5, and 20% discount. So I would have to multiply this value by 0.8. So let me go to monthly charges. So 1, 2, 3, 4, 5. So this was the initial value 70. Right. Now I will select all of this, paste it over here, and I'll store the result back to the same cell. So this will be customer churn dollar monthly charges, cell number is 5. Let me have a glance at the data set now. Let us see the result. So we have our monthly charges. So initially it was 70, and after giving this guy a discount of 20%, his monthly charges came down to 56. Right, so we are also done with switch. Then we have looping statements. So these looping statements basically keep on repeating a certain action, like keep on printing your name for 1,000 times, or keep playing the music for the next 1 hour. Right, so let's go ahead and work with this looping statements. So I'll start with for loop. Now we have this gender column over here, and I'll use the for loop to count the number of male customers. Right, so I will type for, and over here I'll give a variable, and I'll name this variable to be I. This is the vector. So I'll give a range over here. So for I n 1 is to n row of customer churn. So that is, this loop will run starting from 1 to 7043. Right. Now in this entire loop, I need to check number of male customers. So for that, I will use the if condition. So if customer churn $gender is double equal to male. Now I will create another variable over here and give this to be 0. So if customer churn $gender, again I need to give the cell which is I over here. So if customer churn $gender, I is double equal to male, then I will increment the count value. So count will be count plus 1. Right, so what is happening is initially I value is 1. So now this will be evaluated to true. And again over here I am checking if customer churn $gender, the first cell value, if this is equal to male, then I'll increment count with 1. Again this loop will come over here, I value will be 2. Over here we'll check if customer churn $gender 2. So this is male again, so count's value will be increased to 2. Similarly then I's value will be 3, and we'll check the cell number 3 over here. Cell number 3 is male again and again, so the count value will be incremented and it'll be 3 now. So this is how this loop will go on. So let me print this over here. Let me print count. So we see that there are 3,556 male customers. So let me verify this with the help of table function. So I'll type table of customer churn $gender. And we see that this is actually true. There are 3,556 male customers. Right, so this was for loop. Now we'll go ahead and understand the while loop. Now with the help of while loop, we will get a count of the number of customers whose payment method is electronic check. Right. So now I will delete all of this. I will give a new variable which is I is equal to 0. I will create the while loop over here. I'll give a condition. So I will check if I is less than n row of customer churn. That is, if 1 is less than 7043. So this actually needs to be less than or equal to 7043. And if this is true, I'll go ahead and check my condition. If customer churn $payment method, here I'll give the cell number which will be I. So if this is equal to electronic check, then I will increase the value of count with 1. So count will be count plus 1. Right. So after doing this, I will also increment the value of I. So I will be I plus 1. So let us understand this properly. So I am checking if 1 is less than or equal to 7043, which is evaluated to true. And since this is evaluated to true, then I am using the if condition to check if the cell number 1, the payment method is electronic check. So since this is electronic check, the value of count is incremented. Now after this if condition is done, I am incrementing the value of I over here. Now I's value will be 2. Then I'll check if the value over here is electronic check or not. Similarly, this loop will continue on. So let me go ahead and select all of this and print it over here. I'll type count. Now let me verify this. So table of customer churn $payment method. So see that the number of customers whose payment method is 2365, and over here we have got the count to be 2365. Right, so we are done with while loop. Then we have user defined functions. So these basically help us to modularize our entire program. Let's say if we wanted to find out the minimum and maximum values of every column. So all we need to do is create two functions, min and max, which can be applied on all the columns. So let's go to RStudio and create some user defined functions. Right now, again, I'll create a user defined function to get a count of number of male customers. I will name the function to be gender count. Now this is the syntax of a user defined function. So I will type function, and this is our parameter over here. Right. Now inside this, I need to write the entire code to find out the count of the number of male customers. Right. So I'll be using the for loop again to do that. So I will type for I in 1:, length of x. Right. And over here, I will check if x of I is double equal to male. And if it is equal to male, then I'll say count is equal to count plus 1. Again, I will create a new local variable over here, count, whose initial value is supposed to be 0. Right. So let's go through this function again. So this is the syntax of a function, and I am naming this function to be gender count. So over here, I will send this gender column as the parameter. Now, once I do that, I have initialized local variable where count is equal to 0. And over here, the loop starts. So for I in 1 is to length of x. So length of x, that would be the length of this column, which would be 7043. So this loop will go from 1 to 7043. Right. And inside this over here, we check for each and every cell. So if x of I, so for first iteration, it will be x of 1. So we'll check for this cell. So if this value is equal to male, then count's value is incremented by 1. Again, i's value is 2, and if the value in the cell is male, count's value is also incremented by 1, and this goes on. After the entire loop is done, I'll also print the value of count over here. Alright, so I will select all of this and I will paste it over here. So we have our function to be ready. Right, so gender underscore count, and I will send the gender column as the parameter. Right, so we get a value of 3556. Let me verify this again. Table of customer churn $gender. Right, so we see that number of male customers is 3556. So now the best part of functions is we just need to make a small change over here if we need to find out the number of female customers. So all I'll do is I will change this to be female, and I can pass in the same column to find out the count of number of female customers. Right. So I will use this function again, gender count, and I'll say customer churn $gender. I'm sending this as the parameter. Now let us see the count. Let me verify this. So I will type table of customer churn $gender. And over here we see that the number of female customers are 3487, and that is the same value which we've got with the function. Right, so this was an implementation of user-defined function. We'll work with the basic data structures in R. So we'll start with one-dimensional data structures, which are vectors and lists, and then we'll head on to matrices and arrays, which are multi-dimensional data structures. So the most basic data structure in R is a vector. It's a homogeneous unidimensional object. So what do I mean by homogeneous? Well, all of its elements must be of same type. Like over here, we have a collection of birds linearly arranged. Now let's go ahead and implement this in R. Alright, so we are back to our studio. I'll start off by creating a character vector, and I'll name it as bird. And I'll go ahead and give down some names of birds. So our first bird would be eagle. Then we have parrot, and our final bird would be pigeon. Now let me print this. Right, and let me also go ahead and check the class of this vector. So I'll type class of bird. Right, so we see that this is a character vector. That is, all of these three elements are actually characters. Now I'll be creating an integer vector, and I'll name this as numbers. So I'll just list down the numbers from 1 to 9. Let me print this now. So this is a vector which comprises of numbers from 1 to 9. Let me go ahead and check the class. So I'll type class of numbers. So this is integer. Then we have a numeric vector type. So in numeric, we can give floating point or decimal values. So I'll name this to be decima, and I'll give some floating point values. So I'll just give some random floating point values over here. Let me print this. Now let me check the class. So I'll type class of decima. So see that this is of numeric type, right? And then finally we have a logical vector. And in logical vector, we can just have two values, either true or false. So I'll name this to be logit 100 and give out some logical values, true, false, and if I'm too lazy, I can just give T and F like this over here, right? So let me print this logit 100, right? So these are all of the values of this vector. Now let me check the class. So I'll type class of logit 100. So see that this is of logical type. So this was an implementation of vectors in R. So then we have a list. So a list is a heterogeneous collection of elements. That is, the elements do not have to be of the same type, and each element actually retains its own identity even when it is present in the list. Like over here, we have a heterogeneous collection comprising of a bird, an apple, and a car. So let's head to R and work with list. So this is how we create a list. I type out list, and let's say the first element is the integer 1. Then I'll give a character value, and I'll name it to be Nirvana. After that, I'll give a logical value, and this is true. I'll store this in mix bag. Right. So let me print mix bag over here. So this is how our list looks like. So we have three elements. First is integer, next we have character, and then finally we have a logical value. So let me check the class of this object. So I'll type class of mix bag. So you see that this is a list. Now I'll also go ahead and check the class of individual elements, right? So I'll type class of mix bag, and I'll give two square braces, and I want to check the class of the first element, right? So we see that it is numeric, second is character, and the third element is logical, right? So let me actually print the list for you guys. So this number 1 is of numeric type, this element Nirvana is of character type, and this element true is of logical type. So we see that all of these three elements retain their original identity or their original classes. So this is how a list functions. Next in line is a matrix. So matrix is a homogeneous collection of elements in two-dimensional space. So over here, all of the elements belong to the same category, namely fruits, and they are arranged in the form of rows and columns. So now let me go ahead and implement matrix in R. Alright, so to create a matrix, what I'll do is I'll actually be using the same vector first. So let me have a glance at this. Right, so now I'll be inserting all of these elements into our matrix. Right, and to create a matrix, I will type matrix. So the first parameter is the data. So for the data, I am giving the numbers vector. After giving the numbers vector, we have two other parameters where we specify the number of rows and the number of columns that we want. So let's say since we have 9 numbers in total, I would want this to be a 3 cross 3 matrix. That is, n row is equal to 3, or number of rows is 3. And similarly, n col is 3, or in other words, number of columns is 3. And I will store this in mat1. So let me print mat1 now. Right, so this is our matrix over here, where all of these of same type 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all integers, and I'm storing them in the form of rows and columns. And what you see over here is these elements are arranged column wise. So if I want to arrange these by row, then what I'll do is we have the by row attribute, and I'll just set it to be true. Right, and I'll print mat1 now. So you see the difference over here. So now the elements are arranged by row. 1, 2, 3, 4, 5, 6, 7, 8, 9. Initially they were arranged with respect to column. Now they are arranged with respect to row. Right. So now I'll create a character matrix. So what I'll do is I'll create a character vector first and list down some characters. So let's say I will give the first 6 alphabets. So A, B, C, D, E, and F. Right. So I have created a character vector naming alpha, and this consists of 6 elements. All right. Now I'll take this vector and create a matrix. Matrix. The data is coming from alpha vector. Now, since there are 6 elements in total, I want this to be a 2 cross 3 matrix. Right, so number of rows is 2 and number of columns is 3. And I will store this in, let's say, mat underscore alpha. Let me print this now, mat underscore alpha. All right, so this is a matrix over here. So 2 rows and 3 columns. Now again, if I want to arrange this with respect to row, all I need to do is set by row to be true. Now again, I'll be printing mat alpha. Right. So this was with respect to columns. This is with respect to rows A, B, C, D, E, F. Right. So we have also created the matrix. Now, what if you wanted to access the individual elements of the matrix? So this is how we can do it. So let's say I would want to access this element over here. So all we have to do is set the index values. So this is present in the first row and second column, right? So I'll give 1, comma, and we have successfully extracted this element over here. Similarly, if you wanted to extract this element F over here, so this is present in second row and third column, right? So mat alpha 2, comma 3, and we have successfully extracted the element F from this matrix. Right, so this was an implementation of matrix.
Just a quick info, guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now let's continue with the session.
And finally, we have arrays. So this is just an extension of matrix. That is, it is a homogeneous collection of elements in n-dimensional space. So let's actually go ahead and implement arrays in R. All right, so what I'll do is I'll create a new integer vector and give out values from 1 to 9, and I'll create a second integer vector, and in this I will give the value starting from 10 to 18. So we have created 2 numeric vectors over here, and we'll be using these 2 numeric vectors to create an array. So this is the syntax to create an array. I'll type array and I'll give out the data. Right, so the data is coming from these 2 vectors. I'll use the combine function and give out these 2 vectors over here, num1 and num2. Right, after this I need to set the dimensions, that is the number of rows, the number of columns, and the number of dimensions. Right, so the dim will be, so in total we have 18 elements. So we have 9 elements in num1 vector and 9 elements in num2 vector. So what I need is actually 2 matrices of 3 cross 3. So I will give 3, comma 3. So this is the number of rows and number of columns, and since I need 2 matrices of this type, so I'll type in 2, and I will store this in array 1. Now let me go ahead and print array 1. So this is a resultant array, right? So this is all of the elements from num1 vector which are stored in this part over here, and then we have all of the elements from the num2 vector which are stored in the second dimension over here. Right, now so how can we access individual elements from this? So let's say I would want to access this element number 15.
So let's go ahead and access this. I will type array1. Now let me check where is this present. So this is present in the third row and second column. So I'll type 3, comma 2. And after this, since this is present in the second matrix or the second dimension, I'll give in 2 over here. And let me check the result. And voila. So we have successfully extracted 15 from this. So similarly, if I wanted to extract this element 5, so let's go ahead and do that. So let me actually, yeah, I need this now. So I will type array 1. And this is present in second row and second column. So I'll type 2, comma 2. And since this is present in the first dimension itself, so I'll give out 1 over here. Right, and I have also extracted 5.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash. A. Packages. B. Functions. C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
We'll be working on a project. So this project would be on recommendation engine. So have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So our dataset for the case study comprises of these 4 files: ratings.csv, books.csv, booktags.csv, and tags.csv. So as the name suggests, ratings.csv contains all users' ratings of the books. So there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Alright, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our data sets, guys. So we have the ratings dataset, which comprises of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings data set by user ID and book ID. After which I am using the mutate function, and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. and I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of N. Right, so let's have a glance at these two cases over here. So the user number 4206 has rated the book number 8945 two times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book, right? So this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given. And I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that.
I have again given ratings over here, and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we'd want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again, and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off, and I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users. And I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So end row of ratings. So now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column.
And after that, since we'd have to make a bar plot, I am using the geom bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what you get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1,500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we have to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID. After which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938. And for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the dataset in descending order. And after arranging the dataset in descending order, I will also left join the tags dataset to the book tags dataset. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got our dataset ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom_bar function. And the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange and red. And the label which I've given for the y-axis is percentage and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent dataset, or in other words, most of the books belong to the fantasy genre and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So up next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order. And that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating. After which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Right guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books data set, I am arranging it in inverse order of the ratings count column, and then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model. And then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit. So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs, and I'm also extracting all of the unique book IDs, and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID, and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column, and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose, and I will store it in a new object and name that object to be rating mat.
Just a quick info guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating metrics. So first we'd have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.metrics function, I am converting the class of rating mat from a data frame to a matrix, and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book, and so on. Right, so we have our rating metrics ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this dim of rating mat 0. So we have the same number of rows and columns. So again here the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function and I am converting this rating mat 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this we would need the new function, and with the help of new function, I am converting this sparse ratings object into a real rating matrix. So this over here takes in 2 parameters. So the first parameter is basically what we are trying to convert this into, and then we given the data which we are trying to convert, and I'll store this result in real ratings object. Let me print real ratings now, and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function, and I will generate true or false values over here, and this sampling would be with replacement, and the probability is 80-20. That is, I would want to divide the data set into two parts, where the first part would comprise of 80% of all of the observations, and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in two parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is unrecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we'd want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF. And then we'd want to predict on top of the test set. So the test set is rec test. And the number of books to be recommended is 6, which is stored in unrecommended UBCF. And I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF at the rate items 1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are present at columns 2177, column number 6343, column number 423, column number 1908, column number 2274 and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF we have the item labels, and inside the item labels I will give in the book numbers which have been recommended. Right. So these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name, where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name, where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see, what do we get? 3029. So the book recommended is Rage of Angels and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @ tag and extracting the items for user number 5, and I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @ item labels, and inside this I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days and it's been written by R.K. Narayan and Jumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors and it has been written by Eric Segal. Right guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users.
Just a quick info guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So our dataset for the case study comprises of these 4 files: ratings.csv, books.csv, booktags.csv, and tags.csv. So as the name suggests, ratings.csv contains all users' ratings of the books. So there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. All right, now after which I'll load the 4 files from our data set. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our data sets, guys. So we have the ratings data set, which comprise of these 3 columns: book ID, user ID, and the rating. Then we have the books data set, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings data set by user ID and book ID. After which I am using the mutate function, and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N, and I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these 2 cases over here. So the user number 4206 has rated the book number 8945 2 times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function, and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book, right? So this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1. So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am storing this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given, and I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here, and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we'd want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again, and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off, and I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So you see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users, and I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So in row of ratings, so now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what we get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1,500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. Right, so these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash. A. Packages. B. Functions. C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we had to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID, after which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938, and for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the data set in descending order. And after arranging the data set in descending order, I will also left join the tags data set to the book tags data set. And the joining would be done by the tag ID column over here.
So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got a data set ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function, and the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and not vertically. And the color to these bars would be determined by this palette over here. So this is YLORD. So this would be for yellow, orange, and red. And the label which I've given for the y-axis is percentage, and the label which I've given for the x-axis is genre. Let me hit enter. Right guys, so this is the plot. So here I have mapped genre onto the y-axis, percentage onto the x-axis. So we see that fantasy is the most prevalent data set, or in other words, most of the books belong to the fantasy genre, and the least percentage is of the cookbooks. So this was the distribution of the percentage of different genres. So next we'll go ahead and find the top 10 books with highest rating. So this would be the command for that. So if you have to find out the top 10 books with highest rating, all we have to do is arrange this average rating column in descending order. And that is what we are doing over here. So here I have given the name of the object, which is books, and I am arranging this data set in inverse order of average rating, after which I am selecting just the top 10 records, and the columns which I'd be selecting are title, ratings count, and average rating. So let me store it in top 10. Let me have a glance at top 10 now. Right guys, so these are the top 10 highest rated books. So the Complete Calvin and Hobbes is the book with the highest rating. So it has the highest average rating of 4.82. And then we have Words of Radiance. So it has a rating of 4.77. Third in place is the Harry Potter box set, which has 4.77 rating. Fourth is ESV Study Bible, which has a rating of 4.76. Fifth in the list is Mark of the Lion Trilogy, which has an average rating of 4.76. Right guys, so we have successfully found out the top 10 books with highest ratings. Next we'll go ahead and also find the top 10 most popular books. So this would be the command for that. So to find out the top 10 most popular books, we'd have to arrange this ratings count column in descending order. That is, whichever book has the most number of ratings, it would automatically mean that it is the most popular book. Right, so this is the command for that. Let me run it over here. So here what we are doing is, on the books data set, I am arranging it in inverse order of the ratings count column. And then I will be extracting the top 10 records, and I'll be selecting the title column, the ratings count column, and the average count column. So let me store this in top popular. Let me have a glance at top popular. Right, so these are the top 10 most popular books. So the most popular book in the list is The Hunger Games, which has the highest ratings count. Then the second most popular book is Harry Potter. Third most popular book is Twilight. And the fourth most popular book is To Kill a Mockingbird. In the third phase, we'll finally do some recommending. So we'll start off by building the user-based collaborative filtering model. And then we'll recommend 6 new books for 2 different readers. Right guys, so it's finally time to recommend some books. So before we go ahead and do that, we'd actually have to restructure our data a bit.
So our data actually needs to be in the form of a matrix where all the rows should correspond to the users and all the columns should correspond to the books. So the dimension names would then nothing be but the user IDs and the book IDs. So the user IDs would represent all of the rows and the book IDs would represent all of the columns. So let me go ahead and extract all of the dimension names first. So here with this command, what I'm doing is I am extracting all of the unique user IDs and I'm also extracting all of the unique book IDs and I'm storing them in this object dimension names. So this is our first task. So we have basically got all of our dimension names. Now we'll go ahead and convert the format of our data frame from long format to wide format. So with this command, what we are doing is we are actually selecting the book ID, the user ID and the rating columns from this data frame over here. And I'll be splitting this book ID column. That is, this value of book ID 1 would become one column. This value of book ID 2 would become the second column. This value of book ID 3 would become the third column and so on. And these rating values over here, they would become the values for the corresponding book IDs. So this is how we can use the spread function to spread out our data frame from long format to wide format. And we'll also remove the user ID column because it doesn't serve a purpose. And I will store it in a new object and name that object to be rating mat. So let me hit enter. Right, so we have created our rating matrix. So we have created the rating mat object. Now let me have a glance at the class of this. So class of rating mat. So we see that this is still in the form of a data frame, but we can build our user-based collaborative filtering model only on top of the real rating matrix. So first we'd have to go ahead and convert this data frame into a matrix. So let me do that. So here with the help of as.matrix function, I am converting the class of rating mat from a data frame to a matrix and I am storing the result back to rating mat. Right. So now let me have a glance at the class. So class of rating mat, and we see that now it is a matrix. So let me have a glance at the first 5 rows and the first 5 columns of it. So these are the first 5 rows and these are the first 5 columns. So we see that this user ID column has not been removed. So let us go ahead and manually remove these. So what I'm doing is I am manually removing this first column and I am storing it back into rating mat. Now let me have a glance at first 5 rows and first 5 columns. Right. So these are the first 5 rows and these are the first 5 columns. So these rows basically correspond to all of the user IDs and these columns basically correspond to all of the book IDs. So these NA values which you see over here, so this basically means that the first user has not rated the first book, the first user has not rated the second book, similarly the fourth user has not rated the third book and so on. Right, so we have our rating matrix ready. Now let me also assign the dimension names to the dimension names of this rating mat object. So here I am assigning all of the dimension names which I've extracted to the dim names of the rating mat. Right. So now let me have a glance at the dim names of rating mat. So dim names of rating mat. So these are all of the dimension names for the rows. So this is the name for row number 1, this is the name for row number 2, and this is the name for row number 3. So this basically signifies that all of the rows are represented by the user IDs. Similarly, if I go down, then we have all of the book IDs. So all of the columns are represented by the book IDs over here. Now let me use the dim function to find out the number of rows and columns in the matrix. So we see that there are 900 rows and 8,431 columns. Or in other words, there are 900 users and 8,431 books. So we have got our metrics ready, but we can't just build a user-based collaborative filtering model on top of the metrics. So we have something known as a real rating matrix. And the recommender lab basically works only on this type of object. So I will store this rating mat into a new object and name that object's name to be rating mat 0. Let me again have a glance at the number of dimensions of this. Dim of rating mat 0. So we have the same number of rows and columns. So again here, the number of rows are 900 and the number of columns are 8431. Now after this, what we'll do is, wherever we have NA values, we will replace those NA values with 0. So in rating mat 0, wherever we find NA values, I am replacing those NA values with 0. So now let me again have a glance at the first 5 rows and the first 5 columns of this. So it'd be rating mat 0, 1 to 5 and 1 to 5. So we see that all of the NA values have been replaced with zeros. So now we can go ahead and convert this matrix into a sparse matrix. So I'll be using the as function and I am converting this rating mat 0 object into a sparse matrix, and I will store this in a new object and name that object to be sparse ratings. Now let me again have a glance at the first 5 rows and first 5 columns of this. So sparse ratings 1 to 5 and 1 to 5. So this is how a sparse matrix looks like. So basically with the help of a sparse matrix, we end up saving a lot of space. Now it's the last part of the transforming. So we will go ahead and convert this sparse matrix into a real rating matrix. So for this we would need the new function, and with the help of new function I am converting this sparse ratings object into a real rating matrix. So this over here takes in 2 parameters. So the first parameter is basically what we are trying to convert this into, and then we given the data which we are trying to convert, and I'll store this result in real ratings object. Let me print real ratings now and let's see what do we get. Real rating. So this is what we get. So it is a rating matrix where there are 900 rows and 8431 columns, and it is of class real rating matrix with 18,832 ratings. Right. So we finally have our real rating matrix ready. So now we can go ahead and build a model on it. So what we'll do is we'll go ahead and split the data set into train and test sets. So it'll be a 80-20 split. So I'll be using the sample function to create this 80-20 split over here. So I am using the sample function, and I will generate true or false values over here. And this sampling would be with replacement, and the probability is 80-20. That is, I would want to divide the data set into 2 parts, where the first part would comprise of 80% of all of the observations, and the second part would comprise of 20% of the rest of the observations. And I will store the split criteria in a new object and name that object to be split book. So now in real ratings, wherever the value of split book is equal to true, I will select all of those records and store those records in rec train. Similarly, from the real ratings matrix, wherever the value of split book is assigned to be false, I am extracting all of those observations and storing those observations in rec test. So we have our training and testing sets ready. Now we can finally go ahead and build our first model. So we'll be using the recommender function, and this over here takes in 2 parameters. First is the training set on which we'd want to build the model, and next is the method or the type of the recommender model which we'd want to build. And since we'd want to build a user-based collaborative filtering model, we'll given the type to be UBCF. So if we wanted an item-based collaborating filtering model, then the method would be IBCF. But in our case, since we want user-based collaborative filtering model, so the method would be UBCF, and I will store the result in an object which would be rec model UBCF. Right, so I have successfully built the model. Now I'll give a value for the number of books to be recommended. So I am assigning the value 6 to a vector, and the name of that vector is unrecommended UBCF. So this basically lets us know that we'd have to recommend 6 books in total. Right, so the model building process is done. So let me go ahead and predict the values. So I'd have to use the predict function for this. So over here, this takes in 3 parameters. First is the model which you built. Next is the dataset on which we want to predict the values. And third is the number of values to be recommended. Right. So first we'll given the model which you built, which is rec model UBCF. And then we do want to predict on top of the test set. So the test set is rec test. And the number of books to be recommended is 6, which is stored in unrecommended UBCF. And I will store this result in rec predicted UBCF. Right, so the prediction is also done. Now let me go ahead and find out the item numbers which have been predicted. So now that we have predicted the values, let's go ahead and recommend some books to user number 1. So here we will use this object rec predicted UBCF. So this is the object which we've just built using the predict function. And I'd want to find out the item numbers which have been recommended to user number 1. So this command over here, rec predicted UBCF at the rate items 1. So this will give me the column numbers which have been recommended to user number 1. So let me have a glance at user 1 book numbers. So this basically means that user 1 has been recommended to read these books which are present at columns 2177, column number 6343, column number 423, column number 1908, column number 2274 and column number 2514. Now we just have the column numbers. So let's actually find out the labels for these column numbers. Right, so from rec predicted UBCF, we have the item labels, and inside the item labels, I will give in the book numbers which have been recommended. Right, so these are the item labels. So the book ID, which is under column number 2177 is 2636. The book ID, which is under column number 6343 is 7482. Similarly, the book ID, which is under column number 2274 is 2750. So we have successfully got the book IDs. So now that we have the book IDs ready, let's actually use these book IDs to extract the name of the book and the name of the author. Right, so what I'll do is I will extract the title of the book and the author's name, where the book ID is 549. So the name of the book is Cordry and the author's name is Don Freeman. Similarly, let me extract the title and the author's name, where the book ID is 2750. So here we see that the book recommended is Mrs. Pigglewiggle and the authors are Betty McDonald and Alexandra Boyger. Similarly, let me extract the titles for the book ID 3029. Let's see what do we get. 3029. So the book recommended is Rage of Angels and the author is Sidney Sheldon. Right, so these are the 6 books which have been recommended, and this is how we can extract the name of the book and the author of the book. Now similarly, let's also go ahead and recommend 6 books for the user number 5. So this is what I'd have to do. I will be using the rec predicted UBCF object, and I'll be using the @tag and extracting the items for user number 5. And I'll store this result in user 5 book numbers. So now that we have the item numbers, let's actually extract the column numbers for each of these items. So for this, the command would be rec predicted UBCF @item labels. And inside this, I will give in the book numbers. Right, so these are the book IDs which have been predicted. Right, so similarly, let's extract the title and authors for some of these book IDs. So we are extracting the title and the author's name, where the book ID is 4624. So the recommended book, so the name of the recommended book is The Girl Who Circumnavigated Fairyland in a Ship of Her Own Making, and the author is Catherine M. Valentine and Anna Wan. Similarly, let's extract the name of the book and the author's name, where the book ID is 6867. So here the book is Malgudi Days and it's been written by R.K. Narayan and Jhumpalari. Now let me extract the title and the author's name for the book ID, which is 7326. So the book's name is Doctors and it has been written by Eric Segal. Right, guys, so we have successfully implemented the user-based collaborative filtering model, and we have recommended 6 books to 2 different users.
Just a quick info, guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Python and R are the two most commonly used languages in data science. And nowadays, most of the freshers get confused whether they should use R or Python to kickstart their career in the field of data science. And in this video, I'm going to tell you the long and short of both of these topics. So, without wasting more time, let's get started. I'm going to start off with their basic definitions. So, starting off with R. R is a programming language made by statisticians and data miners for statistical analysis and graphics supported by the R Foundation for statistical computing. R also provides high quality graphics, and it also has some popular libraries which help in analytical parts such as R Markdown and Shiny. Python, on the other hand, is a fully fledged object-oriented and high-level programming language made by programmers and developers for general-purpose programming. Python is widely used in graphical user interface-based applications such as games, graphic designs, web applications, and many more. So we can say that R's functionality is developed by statisticians' mind, thereby giving it a field-specific advantages, while Python is often praised for being a general-purpose language with an easy-to-understand syntax. Let us start from the first factor, that is the speed. So guys, when it comes to speed, Python is faster than R only till 1000 iterations. But after the 1000 iterations, R starts using the Lapley function, which increases its speed. In that case, R becomes faster than Python. So both have their own advantages, right? Moving forward to the next point, that is the code and syntax. In this topic, I'm going to give you a brief about the variable declaration, data handling capacity with the scatterplot visualization, and the class plot graphics. Starting off with variable declaration. So guys, I'm going to take the case of string here, as R uses a similar implementation to that of the S programming language, which uses arrow signs in order to initialize the variable, which was also present in case of S programming language. These arrows can be used from right to left or left to right, indicating whom to assign the variables, whereas Python uses an assignment operator to initialize the variables. So basically, our developers thought that it would be better to tell the direction of assignment rather than just using an assignment operator, which could actually confuse any new programmer about which variable is being assigned. Right. Next is the data handling capability. Here, I'm going to show you the case of scatter plots, by which you will see the visualizations in R and Python. So guys, these are the piece of codes in R and Python, and after running these codes, you will get the very similar plot results in both the cases. If you try to analyze this code right here, then this clearly shows that how our data science ecosystem has many smaller packages like ggalley, which basically is a package that helps ggplot2, and also it is mostly used in R plotting package. Whereas in Python, matplot library, or we can call it matplotlib, is the primary plotting package, and seaborn is a widely used layer over the matplot library. So guys, these are the plot results that I was talking about. So you can see that the graph results of both R and Python are similar, but the only difference is the visualization. Right. So based on these points and plot results, we can conclude that R has many packages supporting different methods of doing things, whereas there is usually one way to do something in Python. Moving on to the next point, that is the graphics. So here we will take the case of class plots. So guys, we already discussed that R was basically built for statistical analysis. So it has many specific libraries for plotting as well. This is the reason R comes up with many beautiful charts and graphs, whereas Python's main agenda was not a statistical analysis. So in the early stages of Python, packages for data analysis was an issue, but it has improved a lot. So guys, this is a plot result which is on your screen that I was talking about. As you know that the picture says more than 1,000 words. So here you can see by yourself that R comes up with a beautiful graphical representation. So here we can say that R is handy when it comes to the data handling. Our next point of attention is the deep learning, which is today's trend. So as you all know that almost majority of the companies are working on artificial intelligence, and deep learning is the main part of artificial intelligence. So when it comes to deep learning, Python is more versatile than R, as it provides more features to deep learning, whereas R is new to deep learning. R has newly added APIs like Keras and Keras R, which are written in Python. So guys, somewhere in your mind, this question might be floating. Why Keras? Actually, Keras and Python has the capabilities to run over Python's strong APIs like TensorFlow or Theano or Microsoft's CNTK. So we can say that Python has a greater advantage here. Till now, we have seen that both are useful in their own terms, right? Moving forward, to the next point, that is the percentage of switching. In the past years of research, the percentage of people switching from R to Python are more as compared to Python to R. Let us say if 10% people are switching from Python to R, then 20% are switching from R to Python, which is twice as compared to the before scenario. Next, we are going to look at the trends, community support and jobs. So guys, if we talk about the trends, before 2016, R was more in use. But here we can see that from 2016, Python is in trend. So it is more popular than R. And because of its popularity, it has overall good support for general purpose programming. So guys, if we talk about the community support, then Python's and R's support aspects are quite similar to each other. Because Python support is found at mailing list, user contributed code and documentation and Stack Overflow. So basically it has more adoption from developers and programmers end. Whereas R language support is also found at mailing lists, user contributed documentation and active Stack Overflow members. So basically R has more adoptions from researchers, data scientists and statisticians end. Now if we talk about the job trends, let us check the Google job trends graph right here. So guys, this is the job postings of R and Python in past 12 months worldwide. Whereas Python is asked more as compared to R. How is it possible? Because of its popularity and its need in the current industry. Since Python is more versatile and an all-rounder programming language, which can be used for majority of the purposes such as web application, game development, artificial intelligence, data science, statistical analysis, etc. Whereas R language is used among statisticians and data miners for developing statistical software and data analysis, which clearly depicts that there are more jobs for Python than R. Now let's move forward. So, which one to choose for data science? R or Python? So guys, this is a frequently asked question by the majority of the learners in this domain. I would suggest using both if you have the choice. Everything has their own pros as well as cons. So as in the case of R and Python, if we talk about pros in R, well, then R is great for prototyping and for statistical analysis. It has a huge set of libraries which are available for different statistical type analysis. Even RStudio IDE is definitely a big plus as it eases most of the tedious tasks and fastens your workflow. Talking about its cons, well, the syntax could be obscure sometimes and it is harder for it to integrate to production workflow. The library's documentation isn't always user friendly. Talking about the pros in Python, Python is great for scripting and automating your different data mining pipelines. It is the de facto scripting language nowadays and it also integrates easily in a production workflow. Besides, it can be used across different parts of a software engineering team like for backend, cloud architecture, etc. The scikit-learn library in Python is awesome for machine learning tasks. Talking of its cons, then Python isn't as thorough for statistical analysis as R, but it has come a long way in these recent years. In my opinion, the learning curve is steeper than R, since you can do so much more with Python. To conclude it, I would like to say that you can use R and Python both. Learn and how they interoperate together. Start with one and then add another to your workflow. It only adds another skill set into your resume, which comes as an added bonus to your career, isn't it?
Just a quick info guys. Test your knowledge of R programming by answering this question. Which of the following is used for statistical analysis in R language? A. Studio, B. RStudio, C. Heck. Comment down your answer in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now let's continue with the session.
Now let us begin with our programming interview questions and answers. So the first question is, we have to compare R and Python. So what are the differences in R and Python? So starting with R programming, it helps in model building and it is similar to Python. And talking about Python programming language, so it is also used for model building similar to R. So these are the common things or a common objective that is achieved using R as well as Python programming. Then talking about R programming, model interpretability is good. Then in Python programming or using Python programming, model interpretability is not good as in comparison to R programming. Then coming to production, so production is not better than Python in R, and Python provides a better way and more functionalities, packages and libraries for the production of the model. Then R has good community support over Python, and community support in Python is not better than R. There are more professionals and there is a large community of R developers. Then comes in R, the data science libraries are same as Python, and in Python the data science libraries and packages are same as R. That is, they serve the purpose of data analysis, data manipulation, creating machine learning as well as AI models. So both of these programming languages consist of various libraries and packages that are used in data science. Then R has good data visualizations libraries and tools, whereas data visualization libraries is not better than R in Python programming. So R provides more informative and beautiful graphs in comparison to Python programming. Then for R, it has a steep learning curve, and in Python the learning curve is easier than R because, as you already know, Python is one of the simplest programming language. So these are the points of comparison between R and Python. Now let me go to the next question. Explain the data import in R language. So R provides import data functionality in R language, and data can be imported in R language in three ways, and these are: you can select the dataset in the dialog box or enter the name of the dataset as required in the terminal. Then data is entered directly using the editor of R command prompt via data as new dataset. So you can write it in the command prompt for importing the data. And finally, data can also be imported from a URL or from plain text file or from any statistical package or from the clipboard also. So you can import the data in R using these three ways. Now let me go to the next question. Explain how to communicate the outputs of data analysis using R language. So to communicate the outputs of data analysis, you have to combine the data, code and analysis results in a single document using NITR package, and then what you can do is you can verify the findings or the results and add it to them, and you can then engage the conversation between the outputs of data analysis, and then you can redo the experiments by inserting new data values and applying it to different problems. So you have to add the new data again and again, then you will implement the same code on the updated data and see the analysis. Then you have to verify the analysis or the result you get from the model. So in this way you can communicate the outputs of data analysis using R language. Now let me go to the next question. We'll see the difference between library and require functions in R language. So starting with library function, it gives an error message if the desired package cannot be loaded, whereas in require, the require function is used inside the function and throws a warning message whenever a particular package is not found. Then in library, it loads the packages whether it is already loaded or not, whereas in require or while using require function, it just checks that it is loaded or loads it if it is not loaded. So when you will go through the documentation of the require function, it clearly states that neither function will reload an already loaded package. Now the third point in library function is it is better to use the library as it gives the error message if the package is not found during the package loading time, whereas require function will just fail without an error if the package is not there. So these are the differences between the library and the require function. Now let me go to the next question. What are the advantages of using R programming? So these are the major advantages of R programming, and they are: it is open source. That means the software or the original code or the source code is made freely available and may be redistributed and modified in future. So it is freely available. This is one of the most important thing. So it does not have any charges for using. Then it supports data wrangling operations. So data wrangling is actually the process of transforming and mapping data from one raw data into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as analytics. So we can say that R programming provides us the libraries, packages and features for data analytics. Then it is highly compatible. It is platform independent. That is, we can run the code, or you can say the R codes, in any platform. Finally, it supports machine learning operations. So we can do a lot of things using R programming. So we can perform data manipulation, data visualization, then data exploration, or we can say exploratory data analysis, then creating machine learning models, and it supports a lot of algorithms that we can actually use for building ML based applications. So these are the advantages of R programming. Now let us move on to the next question. What are the disadvantages of R programming? So apart from the advantages of using R programming,
there are certain disadvantages, and these are listed over here. So there is a lack of standard GUI. So when you are using Python for data science or machine learning or for AI, we use Jupyter Notebook, and for R we use RStudio. So you can see the difference between both of these. Jupyter Notebook provides a better GUI that is more easy to go through in comparison to RStudio that we use for R programming. Then R programming is not good for big data. So if you are handling large amounts of data, then you should use Python because it is not efficient for big data. Then comes weak origin. It lacks basic security. It has lesser speed than other softwares that we use for data manipulation, visualization, or creating machine learning models. Then another disadvantage is spread across various packages. Now these are the major disadvantages. Now let us move on to the next question. What is the use of with and by function in R? With function applies an expression to a data set, and syntax, you can see the syntax over here. With, you have to give the data and the expression that you want to execute. So it is a generic function that evaluates expression in a local environment constructed from data, and the environment has the caller's environment as its parent. So this is very useful for simplifying calls to modeling functions, and if data is already an environment, then it is used with its existing parent. Now coming to by function, it applies a function to each level of a factor. So by function in R applies a function to specified subsets of a data frame, and first the parameter of by function then takes up the data, and second parameter is which by the function is applied, and the third parameter is actually the function. So this is the syntax of by function. So here are three arguments: data, factor list, and function. Now let us move on to the next question. In R programming, how missing values are represented? In R, missing values are represented by NA, which should be in capital letters. So NA is not actually a string or a numeric value, but an indicator of missingness. So we can create vectors with missing values. So x1 and x2 are the vectors, and C function is the combine function. So here are the values in the vector, including 1, 4, 3, NA and 7. And in the vector x2 there is A, capital B, NA and NA as string also. So the values which are in inverted comma, so these are strings, and the original NA value is simply written as NA. So there are also the values that are divided by 0 or are represented by the symbol NaN, which represents that it is not a number. So these values are actually the impossible values that are available in the data set. So there are various methods for handling the missing values that we'll discuss later. So here we have discussed about the missing values, how they are represented in R. Now let us move on to the next question. What is the use of subset and sample function in R? So subset function in R returns subset of data frame, vectors or matrices which meet the specific conditions. And this is the syntax of the subset function, which includes X, condition and select, where X can be a matrix, data frame or vector. Then condition is the condition that which you want to impose, the condition that you want to use. So that is denoted by the condition. Then comes select, which denotes the column that are to be selected. Now let us look at an example. So here new data is equal to 30. So there is a data set where there are 30 values. We use the subset function and give the arguments. So the above code select the data from the empty cars table where MPG is greater than or equal to 30, and so the output will be, as you can see, that the values of MPG, CY, L and gear. Now let us look on to the next one, that is sample function. So sample function in R generates a sample of the specified size from the data set or elements, either with or without replacement. So this is the syntax of the sample function, that is the sample keyword, and the arguments are X, size, replace and the prob. So X denotes the data set or a vector of one or more elements from which sample is to be chosen. Then comes size, which denotes the size of a sample. After that replace, so there you need to mention should sampling be with replacement. So you need to give it as true or false. Then comes prob, so it gives the probability weights for obtaining the elements of the vector being sampled. So you can see the example using the sample function. We give the values as 1:20, 10 and replace equal to 2. So when we run the above code, we'll get the output as you can see it on your screen, that is 6, 8, 12, then 19, 5, 18, 19, 14, 13 and 2. So these are the 10 values between 1 to 20 and these are actually the random values. So now let us move on to the next question, that is explain what is transpose. So transpose is used for reshaping of the data which is used for analysis. So rotating or transposing our objects frame so that the rows become the columns and the columns becomes the rows. So that is what we are transposing, and we are actually transposing the rows and the columns. So you can see the example image over here. So the original matrix consists of A, B, C, D, E, F, G, H, I, where A, B, C are in the horizontal frame. After applying the transpose on this matrix, the A, B, C comes in the vertical frame, and same is the case with D, E, F and G, H, I. So this is actually the transpose of a matrix. So we apply transpose in a matrix in our programming so that we can analyze the data in different ways. Now let us move on to the next question. Now the question is, why do we use R programming? So R programming is used for data manipulation, data visualization and for creating machine learning models as well as AI based applications. Now starting with data manipulation, as you already know, the data collection process done by machine involves a lot of errors and inaccuracies in reading. So data manipulation helps us to remove these inaccuracies and make the data more accurate and precise. So data manipulation involves modifying the data to make it easier to read and to be more organized. So we manipulate the data for analysis and visualization tasks, and it is also used with the term data exploration, which involves organizing data using available set of variables. So there are many methods and functions in R that we use for data manipulation, such as filter that helps to pick up rows based on their values, then distinct to remove the duplicate rows and to arrange to reorder the rows, then select function that select columns by their names, then rename function is used to rename the columns, mutate function and transmutate function is used to add or create new variables. So by using all these functions, we can manipulate the data, we can remove the duplicacy, we can arrange them in an order that we can easily understand. So in simple words, we can say that data manipulation is a crucial function for any business operations and optimization, and to properly use data and transform it into useful insights like analyzing financial data if you are working for any financial organization such as bank or any other company which is related to finance, then customer behavior and performing trend analysis. So here you have to be able to work with the data in the way you need it. So that is why data manipulation is a very necessary task. So using R programming, we can easily manipulate the data according to our use. Then comes data visualization. So whatever data is collected, manipulated and performed exploratory data analysis on it. So we need to analyze and we need to understand the data in the form of graphs and plots so that we can understand the trend, we can analyze it, we can understand it using certain statistical parameters, we can understand the change in the values and the behavior of the customer as well using data visualization. So data visualization is another important part of business analytics task, or you can say data analysis, or it is used in data science as well. So most of the companies uses data visualization to analyze their business, to analyze their customer, the trends of the market, the behavior of the customer, their buying behavior, their interest. So it helps them to make a proper strategy based on the past data visualized and then optimize their business process for gaining or for increasing their revenues. So R programming provides a lot of libraries and packages and tools that help us to visualize the data in a very efficient way with informative graphs and plots. Then comes machine learning. So we can create various algorithms, we can create various models of machine learning using R programming. So there are various functions, various libraries that are present in R for creating classification, regression, clustering algorithms that are used in machine learning. Also, artificial intelligence is one of the field that is covered by R programming. So we can create image classification model as well as CNN that is convolutional neural network as well, using R programming in artificial intelligence. So we start with data manipulation, then we visualize the data. According to it, we create machine learning models, and we can also create AI based applications using R programming. So this is the use of R programming. Now let us move on to the next question. What is the function used for adding data sets in R? So for adding two data sets, we use rbind function, where the condition is the column of the two data sets must be same. And here is the syntax of rbind function. We have to write the rbind keyword, and then we have to give the argument as x1, x2, where x1 and x2 can be vector, matrix or data frames. So rbind basically stands for row bind. We also use cbind, that stands for column bind, that helps to bind the columns, and here the data or the arguments can be vectors, matrices or data frame. And the condition over here for using rbind function is also that it combines vector, matrix and data frame by rows. So the column numbers of the two data sets must be the same, otherwise the combination will not be effective and it will be meaningless. So if two vectors do not have the same length, so the elements of the short one will be repeated. So that is why the number of the column of the two data sets must be same. So this is about the rbind function. And now let us move on to the next question, which is how you can produce correlations and covariances. So correlations is produced by COR function and the covariances is produced by COV function. So correlation, or represented by R, measures a linear dependency between two variables x and y, and it is also known as a parametric correlation test because it depends to the distribution of the data. So here you can see the graph where the correlation is represented. Now coming to covariance, it is a statistical term used to measure the direction of the linear relationship between the data vectors. So here you can see the graph plotted between x and y. So here is positive covariance and the negative covariance. So here you can see the graph for positive covariance and the negative covariance where the data points are spreaded. So in actual words, variance refers to the spread of a data set around its mean value, while a covariance refers to the measure of the directional relationship between the two random variables. And talking more about covariance, it is actually the measure of the joint variability of the two random variables, and here the sign of covariance therefore shows the tendency in the linear relationship between the variables. So in positive covariance, you can see the values or the mean values of the data set are increasing positively, while in negative covariance they are decreasing gradually. So this is about the correlation and the covariances. And now we'll move on to the next question. What is the difference between matrix and data frame? So data frame can contain different types of data. So as you can see in the table that there are x and y columns in this data frame, and x consists of the values 12.3 and 3, 5.01, 2.3, and y consists of mango, orange, banana and grapes. So it can contain multiple data types in multiple columns called fields. So these are called fields. Then coming to matrix, matrix can contain only similar type of data and it has a fixed number of rows and columns. So here you can see the values 12.3, then 3, 5.01, 2.3, and in the next column it has 8.1, 5.2, 3.0 and 0.1. So it can only contain the similar type of data. It cannot have different types of data such as in data frame. Now let us move on to the next question. What is the difference between lapply and sapply? So starting with lapply, so this function is useful for performing operation on list objects and returns a list object of same length of original set. So L in this lapply function stands for list. So we are applying the function on a list. Then coming to sapply, this function takes list, vector or data frame as input and gives the output in vector or matrix form. Then lapply returns a list of similar length, as you already know, and as input list object, and each element of which is the result of applying fun to the corresponding element of the list. Whereas sapply, it is useful for operations on list objects and returns a list object of the same length of original data set. So in sapply, it is useful for operations on list objects and returns a vector of same length of original set. Now in lapply, it takes a list, vector or data frame as input and gives the output in list itself. But in sapply, it does the same job as lapply, but it returns a vector. So this is the major difference between lapply and sapply function. Now let us move on to the next question. How many data structure R has? So there are 5 types of data structures in R that are shown below in the diagram. So it has vectors, data frame, list, matrix and array. So starting with vector, it is one of the basic data structures in R programming and it is homogeneous in nature, which means that it only contains elements of the same data type, and data types can be numeric, integer, character, complex or logical. So vector in R programming is created using the C function, and coercion takes place in a vector from lower to top, and if the elements passed are of different data types from logical to integer or to double to character, so we use that. Then if we want to check the data type of the vector, we can use type of, and for checking the class of a vector, we can use the class function. Now elements of a vector can be accessed by using the indexes that it has inside the brackets to specify the indexes of the elements that are to be accessed, and we can also use logical indexing, negative indexing. Apart from that, we can perform addition, subtraction, multiplication and division on vectors having the same number of elements. Now apart from that, if arithmetic operations are performed on the vectors having unequal lengths, so we can recycle it, and then the vectors elements which are shorter in number as compared to the other vectors are recycled. For example, if we are having a vector 1 containing the value 876501 and we have vector 2 that has 7 and 15, so vector 2 will take the values repetitively of 7, 15, 7, 15 and 7, 15, and when we add the vector, then the corresponding values will be added. So this is how a vector can be recycled. Now we'll go to list. So a list in R programming is a non-homogeneous data structure, which implies that it can contain elements of different data types and it accepts numbers, characters, list and even matrices and functions inside it. So it is created using the list function. Also, the elements of a list can be accessed by using the indices of those elements that are present in that, and we can add and delete the elements only at the end of a list. So this is about the list. Now we'll go to matrix data structure. So the matrix in R programming is a two-dimensional data structure that is homogeneous in nature, which means that it only accepts elements of the same data type, and coercion takes place if the elements of different data types are passed, and it is created using the matrix function. And the basic syntax to create a matrix is you have to give the matrix keyword, and then in brackets you give the arguments as data, number of rows represented by n row, then n column for number of columns, then by row, and the dimensions name. So in data you have to put the input element of a matrix given as a vector, and in number of rows you have to give the number of rows that have to be created, then number of columns, the number of columns that you need to create, then by row function, so the row wise arrangement of the elements instead of column wise, and for that you have to use by row function, and dimension name, so you have to give the names of the columns and rows to be created. So this is the matrix data structure. Now after that, coming to data frame. So data frame in R programming is a two-dimensional array like structure that also resembles a table in which each column contains values of one variable and each row contains one set of values from each column. So the column names of a data frame should not be empty, then row names should be unique, and data stored in a data frame can be numeric, factor or character type, and each column should contain the same number of data items. So this is about the data frame data structure in R. Now coming to arrays in R. So they are the R data objects which can store data in more than 2 dimensions. For example, if we create an array of dimension 2, 3, 4, then it creates 4 rectangular matrices, each with 2 rows and 3 columns. So an array can store only similar type of data, and an array is created using array function, and it takes vectors as input and uses the values in the dim parameter to create an array which represents the dimension of it. So this is about the data structures in R. Now let us move on to the next question. What are R packages? So packages are the collection of data, R functions and compiled code in a well defined format, and these packages are stored in a library. So as you already know, R is a programming language and it is free software environment for statistical computing and graphics supported. So they are the essential tools for various data analysis as well as data science, machine learning implementation. So R language is widely used among statisticians and data miners for developing statistical software as well as implement data analysis technique and implements various data manipulation, data visualization on various types of business data. So this is possible due to the packages that are provided by R. So these packages are actually the development package that help us to visualize the data, manipulate the data and work on machine learning models as well as create AI based applications. So the package over here refers to the development package that is provided by R. Now let us move on to the next question. What is the function which is used for merging of data frames horizontally in R? So there is merge function that is used to merge two data frames. So here is an example. You can see the sum, which is an instance variable, or you can say the object, which will store the output of the merge function where the arguments are data frame 1, data frame 2 and the argument for adding, so by equal to id. So it will add the data frames by their id. So it is a unique variable that are present in both the columns. So this is how we merge the two data frames horizontally in R. Now let us move on to the next question. What is the power analysis? So it is used for experimental design that is used to determine the effect of given sample size. So you can see the graph over here. So it is actually an important aspect of experimental design which is used to detect an effect of a given size with a degree of confidence. So there are various steps for calculating the sample size for doing power analysis. So you can specify a hypothesis test, specify the significance level of the test, then you can specify the smallest effect size that is of scientific interest, and then you can estimate the value of other parameters necessary to compute the power function. So also you have to specify the intended power of the test and then you have to calculate it. So determining a good sample size for a study is always an important issue. So power analysis combines statistical analysis and subject area knowledge and the requirements to help you derive the optimal sample size for your research or study.
Just a quick info guys. If you are interested in learning R programming, then Intellipaat provides an end-to-end R programming course that can help you acquire the right set of skills. So to check the details of the course, you can check out the link given in the description below. Now let's continue with the session.
So there is also a good power analysis value and the desired power level is typically 0.8, but the researcher performing power analysis can specify the higher level such as 0.9 also, which means that there is a 90% probability that the researcher will not commit a type 2 error. And one of the stringent factors in power analysis is the desired level of significance that we use for our data. What is the use of AB line function? So AB line function adds the reference line to a graph, and the R function AB line can be used to add vertical, horizontal or regression lines to a graph. Also here x and y values are single values specifying the intercept and the slope of the line. So here is the syntax for AB line function. So we have to use AB line keyword, then in brackets we have to give the y values and the x values represented or stored in h and v. So these are specifying the intercept and the slope of the line. So this is the use of the AB line function. Now let us move on to the next question. What is iPlots? So it is a package which provide bar plots, mosaic plots, box plots, parallel plots, scatter plots and histogram. So iPlots is actually a package for the R statistical environment which provides high interaction statistical graphs that are written in Java, and it offers a wide variety of plots that you can see over here, that is histograms, bar charts, scatter plots, box plots and many others. So by using iPlots in R, we can actually visualize our data in a much efficient way. So besides these interactive plots, iPlots also provide an API for managing plots and adding user defined objects such as lines or polygons to a plot. And the version 2.0 of it not only adds new multivariate plots and interactive features throughout all the plots, but also lays the foundation for interactive and customizable plots. Now this is about the iPlots. Now let us move on to the next question. What is the use of choregram function? So choregram function is used to plot correlograms. So the cells of the matrix over here can be shaded or colored to show the correlation values. So in the analysis of the data, a correlogram is a chart of correlation statistics. For example, in time series analysis, a plot of the sample autocorrelations versus the time lags is an autocorrelogram. So if cross correlation is plotted, then the result is called cross correlogram. So this is the use of the correlogram. Further, the correlogram is a commonly used tool for checking randomness in a dataset. And if non-random, then one or more of the autocorrelations will be significantly non-zero. So in addition, correlograms are used in the model identification stage for auto-regressive moving average time series models. Now this is all about the choregram function. Now let us move on to the next question. How to create scatter plot matrices? So we use pair or splom function for creating scatter plot matrices. So this is useful to visualize correlation of small data sets, and each scatter plot in the matrix visualizes the relationship between a pair of variables, allowing many relationships to be explored in one chart. Then scatter plots used to visualize bivariate relationships between combination of the variable, that is same as visualization between different types of variables in a same plot. So the scatter plot matrix shows all the pairwise scatter plots of the variables on a single view with multiple scatter plots in a matrix format, and this gives us a more sorted way of representing the data and understanding the relation between the variables as well as visualizing it for further analysis. So here you can see a scatter plot matrix is a grid or matrix of scatter plots that is used to visualize the data and the relationship, and the scatter plot matrix is composed of a grid of mini plots. So there are multiple plots over here and one larger preview plot that shows a selected mini plot in more detail. So there are variables you can see over here that shows sepal length, sepal width, petal length and petal width. Now this is about the scatter plot matrices. Now let us move on to the next question. What is the use of a diagnostic plot? So it is used to check the normality, heteroscedasticity and influential observations. So diagnostic plots actually show residuals in 4 different ways: residuals versus fitted, and used to check the linear relationship assumptions. A horizontal line without distinct patterns is an indication for a linear relationship that implies what is good or what is not good. Then there could be a non-linear relationship between the predictor variable and an outcome variable, and the pattern could show up in this plot if the model doesn't capture the non-linear relationship. And if you find equally spread residuals around a horizontal line without distinct patterns, that is a good indication you don't have a non-linear relationship. Now coming to normal QQ. So this plot shows if residuals are normally distributed. So it also answers the question, do residuals follow a straight line well or do they deviate severely? Then it's good if residuals are lined well on the straight dashed lines. Then coming to scale location, it's also called spread location plot. So this plot shows if residuals are spread equally along the ranges of predictors, and this is how you can check the assumption of equal variance, and it's good if you see a horizontal line with equally or randomly separated points. Now residuals versus leverage. So in this, plots help us to find influential cases, that is subjects if any present in it. So not all the outliers are influential in linear regression analysis, but even though data have extreme values, they might not be influential to determine a regression line. So that means the results wouldn't be much different if we either include or exclude them from analysis. So they follow the trend in the majority of cases and they don't really matter, they are not influential. On the other hand, some cases could be different or influential even if they look to be within a reasonable range of values. So there could be extreme cases against a regression line and can alter the results if we exclude them from analysis. And another way to put it is that they don't get along with the trend in the majority of the cases. Now this is about the use of the diagnostic plots. Now let us move on to the next question, which is define ANOVA function. So ANOVA is used to compare the nested models. So it stands for analysis of variance and is an analysis tool used in statistics that splits an observed aggregate variability found inside a dataset into two parts, that is systematic factors and random factors. So the systematic factors have a statistical influence on the given datasets, while the random factors do not. Moreover, ANOVA is a statistical test for estimating how a quantitative dependent variable changes according to the levels of one or more categorical independent variables. And ANOVA tests whether there is a difference in means of the groups at each level of the independent variable. So this is about the ANOVA function and its usage. Now let us move on to the next question.
Just a quick info, guys. Test your knowledge of R programming by answering this question. R functionality is divided into a number of dash: A. Packages, B. Functions, C. Domains. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
What is the use of MANOVA? So MANOVA stands for multivariate analysis of variance. And by using MANOVA, we can test more than one dependent variable simultaneously. So the multivariate analysis of variance, or MANOVA, is an ANOVA with two or more continuous outcomes or response variables, and the one-way MANOVA tests simultaneously statistical differences for multiple response variables by one grouping variable. So what is the use of MANOVA, or what is MANOVA used for? So this multivariate analysis of variance is a type of multivariate analysis used to analyze data that involve more than one dependent variable at a time, and MANOVA allows us to test hypotheses regarding the effect of one or more independent variables on two or more dependent variables. So the actual difference between ANOVA and MANOVA method is ANOVA method includes only one dependent variable, while the MANOVA method includes multiple dependent variables. So MANOVA is actually used to determine whether there are any differences between independent groups on more than one continuous dependent variable, and in this regard it differs from one-way ANOVA, which only measures one dependent variable. Now this is all about MANOVA. Now let us move on to the next question. What is logistic regression? So logistic regression is used to predict the binary outcome from the given set of continuous predictor variables. So logistic regression is actually a supervised learning classification algorithm used to predict the probability of a target variable. And the nature of target or dependent variable is dichotomous, which means that there would be only two possible classes. So here 0 or 1. 0 represents that it is incorrectly classified output, and 1 represents the correctness of the output. So there are types of logistic regression. So here logistic regression is the proper regression analysis, as you already know, that is used when the dependent variable is categorical or binary. So there are three types over here: binary logistic regression, multinomial logistic regression, and ordinal logistic regression. So in binary logistic regression, only two outcomes are possible, whereas in multinomial logistic regression, there are more unordered categories. And in ordinal logistic regression, there are three or more ordered categories. Now this is about logistic regression. Now let us move on to the next question. Define Poisson regression. So it is used to predict the outcome variable which represents counts from the given set of continuous predictor variable. So Poisson regression actually assumes the response variable y has a Poisson distribution and assumes the logarithm of its expected value that can be modeled by a linear combination of unknown parameters. So a Poisson regression model is sometimes known as a log linear model, especially when used to model contingency tables. So why do we actually use Poisson regression? So it is used to predict a dependent variable that consists of count data given one or more independent variables. And the variable we want to predict is called the dependent variable, or sometimes the response or the outcome, or you can say the target variable. So that is why we use Poisson regression. Now let us move on to the next question. Define cluster.stats function. So it is defined in the FPC package, which provides a method for comparing the similarity of two clusters solution using different validation criteria. So clustering in R is actually a technique of data segmentation that partitions the data into several groups based on their similarity. And basically we group the data through a statistical operation, and these smaller groups that are formed from the bigger data are known as clusters. So talking about cluster stats, it computes a number of distance based statistics which can be used for cluster validation, comparison between clusterings, and decision about the number of clusters. So it can be cluster sizes, cluster diameters, average distances within and between the clusters, then cluster separation. It can be biggest within cluster gap and average widths. So here you can see it in the plot. There are 3 clusters represented by different colors, and we can calculate the cluster diameters, cluster sizes, as well as the distance between the clusters using the cluster.stats function. So this is about cluster and why do we use it. Now let us move on to the last question of this R programming interview questions and answers tutorial. What is principal function? It is defined in psych package, which is used to rotate and extract the principal components. So basically it is just doing a principal component analysis for n principal components of either a correlation or covariance matrix, as you can see in the graph. Also this returns a subset of just the best n factors. So it can show the residual correlations as well, and the quality of reduction in the squared correlations is reported by comparing the residual correlations that we evaluated or calculated to the original correlations. So here are the 2 plots. So first one is transformed non-standardized training datasets after PCA and transformed standardized training dataset after PCA. So you can see the difference after the rotation and using the principal function that is applied for the principal component analysis, and it changes the component as you can see in the plot over here, and it helps to represent the classes differently, and we can make a cluster of it to analyze it in a better way. So this is about the principal function.
Just a quick info guys. Intellipaat provides R programming online training mentored by industry experts. The course link is given in the description below. So here we come to the end of the session. Hope you all enjoyed it. If you have any doubts regarding R programming, then please comment in the comment section below. Thanks for watching.